What does a light year really mean? How far into the past do stars let us see? Could our light one day reach another world? In the quiet hush of a late evening, you find yourself beneath a sky full of stars. The world around you has calmed. The chirping of daytime creatures has faded, leaving only the soft whisper of a night breeze. Overhead, countless stars shimmer gently, like distant lanterns hanging in the dark. You take a slow, deep breath and allow your eyes to adjust, revealing more and more of those faint lights that have always been above you, patiently waiting to be seen. As you lie there, a sense of peace washes over you. The sky feels vast, yet comforting. A familiar friend you've known since childhood, nights spent stargazing. On particularly clear nights, you might see a pale band of light stretching across the darkness. The Milky Way, our home galaxy, quietly glowing with the collected light of billions of distant suns. It arches overhead like a delicate swath of silvery cloud, so soft that you could almost imagine it as a trail of cosmic dust brushed across the sky. You remember perhaps the first time you noticed that glowing band. Maybe you were far from city lights, in a place where the night truly gets dark. At first, it looked like a faint cloud, but unlike a cloud, it didn't move or dissipate. It remained there, steady through the night. It dawned on you that this was something beyond any earthly cloud. It was the combined glow of innumerable stars, far, far away. In that moment, even if you didn't have the words for it, you sensed the enormity of the galaxy that cradles us. Tonight, under that same arch of starlight, you feel a quiet connection to all the dreamers and explorers who have ever gazed upward. The night sky has always been a canvas for human curiosity. So many before us have looked at that milky arc and wondered what it is, what lies beyond it, and if there are other such islands of stars out in the great dark ocean of space. The ancients gave the Milky Way many names: a river of milk, a path of the gods, trying to describe the soft glow they saw. In the stillness now, you simply know it as home, a gentle luminescence marking the vast collection of stars, among which our sun is but one tiny spark. As you continue to stare upwards, you feel the slow turn of the earth. The stars seem to drift, rising and setting in their nightly dance. Time itself feels fluid, stretched out with the slow sweep of the heavens. Your mind wanders and begins to ponder distances. Those stars are not just points of light, they are suns, some like our own, and many wildly different, scattered across unimaginable gulfs of space. The faintest ones, barely visible, could be thousands of times farther than the brighter stars. Even the light from the Milky Way's band has travelled ages to reach your eyes. It's as if you are lying, not just under the night sky, but under a map of the distant past. In this quiet beginning, your thoughts gently turn to those far reaches. How far away are these stars? What does it mean when we say they are far? The stillness of the night invites these questions without urgency, only wonder. You recall hearing terms like light year and parsec, words that measure the gulf between these lights, and you wonder how they help make sense of such overwhelming distances. Above you, a shooting star silently streaks by, a tiny grain of cosmic dust burning up in our atmosphere, reminding you how even small things can briefly light up the vastness. You make a gentle wish, perhaps, or simply let it pass with a sense of awe. Everything is calm The air is cool against your skin. Each star you see is a reminder of how expansive the universe truly is. Yet in this moment, you feel safe and snug on your little planet, looking out from your cosmic front porch. In the silence, a thought arises softly. Beyond the stars of our own Milky Way, there are other galaxies out there, other immense collections of stars swirling in the darkness. What are they like? Could we ever reach them, or even truly comprehend how far away they are? The idea is both humbling and intriguing, and it drifts through your mind like a gentle cloud across the sky. For now, you simply observe and let curiosity guide you. The journey is just beginning. Here, in the stillness of a quiet night, you allow your imagination to take the first steps beyond the familiar. You feel as though you could float upward on a cloud of thought, rising above the earth, carrying that feeling of calm wonder with you into the stars. And as you do, you're gently drawn to explore how we measure the vast distances to those stars and galaxies, and why distance in space is also a journey back in time. With the night as your companion, you are ready to drift further out, to understand the scale of the cosmos that beckons beyond our sky. You let your mind drift to the concept of distance now, trying to fathom how far away those stars and that Milky Band truly are. In our daily lives, distance is simple. A walk down the street, a drive to the next town, maybe a flight across an ocean. We measure it in footsteps or miles or kilometers, and we think in terms of hours or days of travel. But out here, beneath the cosmos, those familiar measures shrink into insignificance. The scale of space is so immense that we need entirely new ways to describe how far things are. And so, astronomers have defined a very special unit, a kind of cosmic ruler, based on the fastest thing we know, light itself. Light moves at a truly astonishing speed. In 1 second, a beam of light could circle the Earth 7 times. Imagine that. In the time it takes you to take a single breath, a ray of light could have raced around the planet and back again many times over. Yet even at that incredible speed, light needs time to travel across the vast distances between the stars. So we use the light year as a measure of distance. It's how far light travels in 1 year. 1 light year is a vast span, about 9 trillion kilometers. That's a 9 followed by 12 zeros, a number that's nearly impossible to picture. Rather than struggle with such an enormous figure, we wrap it up in the simple term light year. And in doing so, we capture the idea of both distance and the time it takes light to cross it. Now, under the starlight, pick 1 star in the sky and let yourself wonder, how distant are you, little star? Suppose it's 10 light years away. The faint glow that touches your eyes left that star 10 years ago, travelling all that time through silent space before finally arriving here tonight. You are effectively seeing that star as it was 10 years in the past. If that star had a sudden change, say, if it dimmed or brightened, you wouldn't know right away. You'd only find out after those 10 years had passed, and the news, carried by light, finally reached Earth. In a very real sense, the distance to that star is also an interval of time. To gaze out at the stars is to gaze back in time. Even our own sun, which feels so immediate and present every day, is far enough that sunlight takes about 8 minutes to reach us. That means the warm rays you feel on your skin in the morning left the sun 8 minutes earlier. In that time, they crossed the empty space between our world and our star. The nearest star beyond the sun, a faint red star named Proxima Centauri, is about 4.3 light-years away. Its light spends over 4 years en route before we ever see it twinkle. Many of the stars you see on a clear night are much farther still, hundreds, even thousands of light-years away. Their light has been travelling through space since long before you were born, long before any city stood, sometimes even before humans existed at all. By the time that ancient starlight reaches your eyes, it has been on an epic journey, crossing an ocean of time and space. Astronomers sometimes use another unit for these vast distances, the parsec. 1 parsec is a bit longer than 3 light-years, about 3.26 to be precise. The term comes from how we can measure a star's distance by the slight shift in its position as Earth orbits the Sun, an effect called parallax. But you need not worry about the technical details. You can think of a parsec simply as another step up on the cosmic measuring tape, just as one might use different units like inches or centimeters for smaller things, and feet or meters for larger things. For the gigantic scales of space, we use light-years or parsecs. These units are our gentle tools for charting the heavens, giving us a way to say, this star is so many light-years away, in a manner that our minds can begin to grasp. There's something poetic about using light to measure distance. Every ray of starlight making its way to your eyes is like a messenger from afar, carrying information about where it came from and how long it travelled. And it works both ways. If you were to stand here with a bright lantern or a powerful flashlight and shine it into the sky, some of the photons from that beam would journey outward indefinitely. Imagine some distant observer, perhaps on a planet orbiting another star far in the future. If they had a sensitive enough instrument, they might detect a faint glimmer from our corner of the universe, a tiny flash of light that you sent, finally arriving after travelling across years or centuries. In that sense, when we look up at the stars and when we shine lights into the sky, we are engaging in a quiet conversation across the cosmos, one that unfolds at the speed of light and over vast stretches of time. As you lie under the night sky, you realize that it is like looking into a time machine. The farther out into space your gaze wanders, the further back in time you peer. The hazy band of the Milky Way that you see is composed of stars tens of thousands of light years away. The light from some of those distant stars began its journey before human civilization began, and it's only reaching us now. And beyond our Milky Way, other galaxies are even farther, their light older still. The nearest large galaxy, the Andromeda Galaxy, is about 2.5 million light-years from us. When you look in its direction on a dark night and catch the faint smudge of its glow, you are seeing ancient light that left Andromeda when early humans on Earth were just beginning to chip stones into simple tools. An entire human prehistory has elapsed in the time it took that gentle glow to cross the intergalactic void and reach your eyes. It's humbling and wondrous to realize how entwined distance and time are in our universe. The cosmos is so vast that the present we perceive is always a collage of many different pasts. Yet, as immense as these distances are, here you are, quietly contemplating them from your patch of ground, connected to those far places by threads of light. Rather than feeling lost, you feel a calm kinship with the universe. You sense that even though you may never traverse these distances physically, your mind and your curiosity can bridge them. It's as if by understanding the concept of a light year, you've built a tiny mental bridge across the void, allowing your imagination to walk among the stars. The vastness doesn't feel cold or forbidding. Instead, it feels like a deep, slow pulse of history and nature that you are now in tune with. Now, with a gentle grasp of how distance is measured out here in the darkness, you can begin to map out where things are. Just as on Earth, we map continents and oceans. In the sky, we can map galaxies. You close your eyes for a moment and picture our Milky Way as just one island of stars in a larger archipelago. It turns out we have neighbours, other galaxies bound to us by the graceful pull of gravity. Together with our Milky Way, they form a small family of galaxies called the local group. You imagine this local group as a kind of cosmic neighbourhood, a cluster of island universes drifting together through the expanse. With your mind's eye, you are ready to float up and see this map of our galactic neighbourhood, to understand who shares this part of the cosmos with us. Floating above our galaxy in your imagination, you begin to make out the presence of other galaxies nearby. The Milky Way is not alone in this corner of the universe. In the vast dark around us, there are other islands of stars, our galactic neighbours, drifting through space together. This small collection of galaxies is what we call the local group. Within it, the Milky Way is one of the major residents, accompanied by two other noteworthy spirals and dozens of diminutive galaxies that sprinkle the surrounding space like a scattering of distant lanterns. The largest companion is the Andromeda Galaxy, often simply called Andromeda. It's another majestic spiral, even larger than our Milky Way, lying about 2.5 million light-years away. If you could see the local group from afar, Andromeda and the Milky Way would stand out as a pair of gentle giant whirlpools of starlight, facing each other across a cosmic pond. They are like two cities in a sparsely populated frontier, separated by a great distance, but bound by a mutual gravitational pull. Between and around them are smaller galaxies, the third largest being the Triangulum Galaxy, a smaller spiral about 3 million light-years from us. Triangulum is like a modest town in comparison to the two great cities. It's fainter and much smaller, yet still a lovely spiral structure in its own right. Scattered around these three spirals is a whole community of tiny galaxies, most much smaller and less luminous. These are the dwarf galaxies. Some orbit the Milky Way, others orbit Andromeda, and a few roam the space in between. Picture them as little boats accompanying the big ships on a cosmic ocean. For instance, our Milky Way has several dwarf companions. Among them, the large and small Magellanic Clouds, which are visible from Earth's southern hemisphere as two faint patches of light. Andromeda, too, is attended by its own retinue of dwarf galaxies, such as two small elliptical companions known as M32 and M110 that huddle near its glowing disk. In total, there are dozens of these dwarf galaxies in the local group, perhaps around 50 that we know of, like a string of lanterns of varying sizes and brightness hanging around the two big spirals. All these galaxies, big and small, are bound together by gravity. They move in a slow dance, orbiting around the common centre of mass of the group or around each other. The entire local group itself spans a region of space several million light-years across. Despite this vast size, It is just a tiny knot in the greater tapestry of the universe. But it is our knot, our little neighborhood in the cosmos. And within it, each galaxy has its own story. The Milky Way, with its spiral arms and star-filled core. Andromeda, with its grand spiral and the promise of a future rendezvous with our own. Triangulum, quietly shining with its subtle spiral pattern. And the dwarfs, some mere smudges of stars, either companion travellers or remnants of galaxies, being slowly swallowed by the larger ones. Looking at this mental map, you feel a sense of place, just as one might feel comfort in knowing the towns and landmarks around one's home. There's a gentle reassurance in knowing that our Milky Way is part of a close-knit collection of galaxies. We are not drifting entirely alone. We have companions journeying with us through the cosmos. If you could point in their directions, you might gesture toward Andromeda over the northern sky, Triangulum nearby, and the Magellanic Clouds in the far southern sky. With your naked eyes, you can only directly see a couple of these. The faint blur of Andromeda on a dark night. The Magellanic Clouds, if you travel far south. The others reveal themselves only through telescopes. But in your mind's eye, you can see them all at once. A quiet cluster of galaxies amid the deep black of space, gently twirling and drifting together as the eons pass. This is our local group, a tiny gathering of galaxies in the vast universe, yet immense beyond ordinary imagination. And within this group, one galaxy especially has long captured the curiosity of sky gazers on Earth, the Andromeda Galaxy. As the nearest spiral galaxy to our own and the brightest external galaxy in our night sky, Andromeda beckons us with its subtle light. Many a night, people have turned their eyes towards that softly glowing presence, drawn by a timeless fascination. Now, let us turn our attention to Andromeda, this great galactic neighbour, and feel the gentle pull it has on our imagination. On a clear, dark night, far from city lights, you might search the sky for a faint, blurred spot of light in the constellation of Andromeda. When at last you find it, just barely visible as a tiny smudge, you are looking at the Andromeda Galaxy. This gentle glow, easily overlooked, is the collected light of 1 trillion distant suns. To the naked eye, it appears as a dim, elongated patch. But what you're really seeing is the nearest spiral galaxy to our own. It's an amazing thought. Without any telescope, just with your eyes, you can glimpse an entire galaxy beyond the Milky Way. There is something profoundly captivating about that faint haze of light. It beckons the imagination, a swirling city of stars lying millions of light years away, yet faintly reaching us here on Earth. Andromeda has drawn the attention of sky gazers for many centuries. Long ago, Persian astronomers noted it as a small nebulous cloud in the night. In Greek mythology, it inherited the name of a princess, Andromeda, and thus the constellation and the galaxy carry a storybook echo from antiquity. Through the early telescope era, people called it the Great Andromeda Nebula, not yet understanding what it truly was. It wasn't until the early 20th century that astronomers like Edwin Hubble uncovered its real nature. By studying faint pulsing stars within Andromeda, they determined it lay far outside our Milky Way, an island universe of its own. That discovery was a revelation. That little patch of light was in fact a galaxy as grand as ours, and our universe suddenly became much bigger in human understanding. In structure, Andromeda is a magnificent spiral galaxy, much like the Milky Way, but even larger. Its disk of stars stretches about 200,000 light-years across, making it perhaps twice the diameter of our galaxy's stellar disk. If we could see Andromeda in its full extent with our eyes, it would appear several times wider than the full moon in the sky. But because most of Andromeda's light is so faint and spread out, only the bright central region is visible to us unaided, which is why we perceive it as a small, blurry spot. Still, within that smudge lies a swirling pinwheel of billions upon billions of stars, with spiral arms, clusters, and nebula, a cosmos in its own right. Telescopes reveal a bright, dense core and sweeping spiral arms marked with blue stars and pinkish clouds of gas. When you realize this, that the faint, foggy oval is actually a sprawling galactic system, it can send a shiver of awe through you. It's as if a single grain of dust on a window turned out to be a distant city full of lights. Andromeda is not just our neighbour, but also our destined dance partner. Over the eons, drawn by their mutual gravity, the Milky Way and Andromeda are slowly approaching each other. In about 4 billion years, unimaginably far in the future, the two galaxies will begin to merge. We call it a collision, but the word belies the gentle nature of this encounter. The stars within them are so far apart that when Andromeda and the Milky Way blend together, very few stars will actually crash into one another. Instead, the two star cities will pass through each other, their shapes distorted by gravity, stars flung into new orbits. Over time, they will settle into a single, larger galaxy, perhaps an enormous, elliptical collection of stars. Future night skies, for any beings alive to see them, will be drastically different, filled with the glow of an altered galaxy. But for now, and for ages to come, Andromeda remains a distinct spiral, quietly gracing our skies, a companion across space that shares this local group journey with us. The lure of Andromeda is more than just its physical presence, it's also what it represents. For humanity, Andromeda has often been a symbol of the beyond, featured in our science fiction stories as a destination for intrepid travelers, and pondered by scientists as a place we might one day send robotic emissaries or distant probes. When you gaze at Andromeda, you are not only looking at a galaxy of stars, you are also confronting the vastness between galaxies. Andromeda challenges us to dream big. It whispers to us about the possibility of other worlds and perhaps other beings living under its light, though we have no evidence of such life yet. Its light is a gentle invitation to wonder, and generations of people have felt that pull. Under the stars, as you observe that faint blur, you might feel a connection to all those who have done the same before you. Ancient scholars, curious stargazers, and modern astronomers. The Andromeda Galaxy has been a fixture in the human imagination for so long. It is both comforting and mysterious, comforting in its steady presence every clear night, and mysterious in what it might contain and what it means for our place in the cosmos. As you continue this quiet journey outward, let's drift our attention to another member of our galactic family. Not far in the sky from Andromeda's position lies a smaller, more subtle galaxy, the Triangulum Galaxy. It doesn't shine as brightly to the unaided eye, but it holds its own delicate wonders. If Andromeda is a great lantern in the dark, Triangulum is like a smaller lantern hanging nearby, softly glowing. Our next stop is this Triangulum Galaxy, a faint little spiral that offers a gentle light of its own in the local group. In the quiet corner of the constellation Triangulum, not far on the sky from Andromeda, lies another galaxy that often goes unnoticed by the casual stargazer. This is the Triangulum Galaxy, also known as Messier 33. Compared to the Milky Way and Andromeda, Triangulum is a shy presence. On an exceptionally dark night, with keen eyesight and patience, a person might barely discern it as an extremely faint patch of light. It's challenging to spot without optical aid, because its light is spread thinly across the sky. Yet it holds the distinction of being perhaps the most distant object that can be glimpsed with the unaided human eye, around 2.7 million light-years away. To many, it remains an elusive target, but that very elusiveness is part of its charm. It's like a small lantern glowing softly at the edge of perceptibility, a gentle reminder that beyond the obvious beacons like Andromeda, there are subtler lights shining in the darkness. Triangulum is the third largest member of our local group, after Andromeda and the Milky Way. It is a spiral galaxy as well, but a modest one. Its spiral arms spread out face-on toward us, meaning we're looking at it from nearly directly above its disk. This orientation showcases its structure, but because the galaxy is smaller and its stars more diffusely spread, it doesn't have a bright central concentration to catch the eye. Instead, Triangulum appears as a ghostly visage, a delicate spiral drawn with a faint hand. It contains only a fraction of the stars of its larger neighbours, tens of billions rather than hundreds of billions. With less mass and light, it quietly hangs in space like a whisper of a galaxy. But what a beautiful whisper it is. Telescopic images reveal a subtle pinwheel pattern, sprinkled with rosy pink nebulae and clusters of young blue stars. Within Triangulum lies one of the largest star-forming regions we know, a colossal cloud of glowing hydrogen where new stars are being born in abundance. If our eyes could see those colours and details, Triangulum would enchant us with its delicate galactic fireworks. Instead, to us, it remains a pale glimmer, hinting at those wonders indirectly. The Triangulum galaxy also shares a gravitational connection with its larger companions. Astronomers believe that Triangulum may be a kind of wayward follower of Andromeda. There are signs it might have passed close by Andromeda billions of years ago. Such a cosmic flyby could have tugged on Andromeda's gas and dust, possibly igniting waves of star formation in Andromeda's disk long ago. Even now, Triangulum is relatively nearby Andromeda, in cosmic terms, only a few 100,000 light-years from it, and it might be bound in orbit around its massive neighbour. We're not entirely certain, but it's poetic to think of Triangulum as a smaller friend or partner to the great Andromeda, dancing around it at a respectful distance. In the grand picture, Triangulum adds to the intricate gravitational ballet of our local group, its presence subtly influencing and being influenced by the others. For amateur astronomers, finding M33 in the sky is a kind of gentle challenge and a quiet delight. Often, they use Andromeda or familiar stars as guides to hop to Triangulum's position, then use binoculars or a telescope to coax it out of the darkness. When it finally appears in the eyepiece, it can look like a tenuous apparition, a faint, oval glow with hints of texture. There's a special satisfaction in detecting it, knowing you are seeing an entire galaxy out there, almost 3 million light-years away, using just your eyes and perhaps a bit of glass. It's a testament to the clarity of space between galaxies, that even a whisper of light can traverse that gulf and still be seen by us. Triangulum may not command the same renown as the Andromeda galaxy, but its subtlety is its beauty. It reminds us that not all of the universe's treasures announce themselves boldly. Some glow gently and wait for us to seek them out. In our journey outward, Triangulum stands as a quiet waypoint, proof that the local group holds wonders great and small, from the grand majesty of Andromeda to the understated charm of this little spiral. As we drift away from Triangulum in our imagination, our eyes turn to the myriad tiny galaxies that surround these larger ones. The Milky Way Andromeda, and Triangulum do not float in solitude. They are attended by a swarm of smaller companions. These dwarf galaxies, like little way stations at the fringes of our galactic neighborhood, beckon us next. In the soft darkness, we will explore these companion dwarfs, those faint galaxies that serve as stepping stones at the edge of home. Hovering on the outskirts of the Milky Way are its tiny companions, the dwarf galaxies that accompany our galactic journey. They are much smaller than the grand spirals we've been exploring, containing only millions to a few billion stars apiece. These diminutive galaxies are like cosmic villages orbiting near a great city. In our local group, they abound. Some huddle close to the Milky Way, some trail behind it, and others cluster around Andromeda. They often go unnoticed, except by careful observers with telescopes. But a couple of them have been known to humans for a long time, visible as faint blurs in the night. They are way stations at the edges of our home galaxy's domain, little stepping stones into the wider universe. In the skies of Earth's southern hemisphere, two such companions stand out. They are the Large Magellanic Cloud and the Small Magellanic Cloud, named after the explorer Ferdinand Magellan, whose crew noted them during their voyages. On a dark southern night, these Magellanic Clouds appear as misty patches hanging apart from the Milky Way's band. The Large Magellanic Cloud, LMC, is the bigger and brighter of the two. Though called clouds, they are in fact galaxies in their own right. The LMC, roughly 160,000 light-years away, floats in a slow, graceful orbit around the Milky Way. It spans about 10 degrees of the sky, 20 times the width of the full moon, though its light is so diffuse that you perceive it only as a pale, cloud-like glow. Within that hazy glow lies a frenzy of stellar activity. The LMC is ablaze with star-forming regions, including the Tarantula Nebula, the brightest stellar nursery in our cosmic neighborhood, where new stars ignite in swaths of glowing gas. The Small Magellanic Cloud, SMC, at about 200,000 light-years distant, is a bit dimmer and smaller. It too contains clusters and nebulae, but it presents as just a little smudge to the eye, like a tiny echo of the Milky Way's light. These two galaxies, wandering around the Milky Way, have captivated southern sky watchers for centuries, serving as natural nighttime beacons for travelers and as subjects of wonder for anyone curious about what lies beyond our own galaxy. Besides the Magellanic Clouds, the Milky Way has other satellites that are too faint to see without instruments. If you could zoom out and look down at our galaxy, you'd see a swarm of these diminutive companions. Galaxies such as the Sculptor Dwarf, Draco Dwarf, Ursa Minor Dwarf, and many others circle our Milky Way at various distances. One, the Sagittarius Dwarf Galaxy, is so close that it's currently being torn apart by our galaxy's gravity, its stars streaming out in loops around us. Andromeda, likewise, has its own cadre of dwarf galaxies, like tiny moths orbiting a lantern. We met two of Andromeda's companions earlier, M32 and M110, each a small elliptical galaxy orbiting near Andromeda's disk. In total, the local group contains dozens of these little galaxies. They often have poetic names derived from the constellations they reside in: Fornax Dwarf, Leothphus, Carina Dwarf, and so on, each one a faint congregation of stars bound together, following the pull of a larger neighbor. Imagine for a moment traveling outward from the Milky Way. After leaving the starry confines of our own galaxy's disk, the first waypoints you might encounter are these dwarf companions. Perhaps you'd pass through the ghostly outskirts of the Sagittarius Dwarf, watching its stars getting assimilated into the Milky Way's halo. Then you might find yourself approaching the Magellanic Clouds. In the sky from within those galaxies, the Milky Way would loom huge and magnificent, a vast, whirling band of light dominating the heavens, far larger than we see it from Earth. That mighty view would remind you how massive our home galaxy is compared to these tiny satellites. Landing on a hypothetical planet in the large Magellanic Cloud, you'd see our Milky Way as a gigantic shimmering arch, a stunning visual testament to the close relationship between a satellite galaxy and its parent. The Magellanic Clouds themselves would have their own charm, a cloudy glow lighting an alien night, with new stars and nebulae visible around you. Though small, the dwarf galaxies play an important role in the life of larger galaxies. They can be slowly pulled apart, their stars added to the halos of the big galaxies, like a kind of galactic nourishment. In fact, much of the Milky Way's outer regions are populated by stars that likely once belonged to galaxies it devoured eons ago. The dwarfs also trigger new stars to form when they interact. Gravitational encounters can send gentle ripples through gas clouds, sparking starbirth like a stone tossed into a calm pond. In this way, the little galaxies continue to influence the giants, even as they are often eventually assimilated. These companion dwarfs are indeed like way stations or signposts marking the edge of our galactic home. They signal that we are leaving the familiar territory of the Milky Way and stepping into the broader realm of intergalactic space. In their quiet, unassuming way, they prepare us for the emptiness that lies ahead. And yet, even between the galaxies, things are not completely empty. The gravity of these interactions draws out tenuous connections, strands of stars and streams of gas that bridge one galaxy to another. If the Milky Way and its companions are like a family, then there are unseen threads holding that family together. To the eye, they are invisible, but to sensitive instruments and to our understanding, they are very real. Gently, we turn our attention to those cosmic threads and streams, the rivers of stars and the shadowy halos of unseen matter that guide them. These delicate structures reveal the relationships and histories of the galaxies in our group. In our next steps, we will follow these faint rivers of starlight and explore the mysterious dark currents that flow alongside them, binding our galactic family together in the vast night. Far out in the halos of galaxies, where the night would be truly dark, there flow rivers of stars. These are the stellar streams, faint, elongated bands of stars that have been pulled from their original homes and set adrift around larger galaxies. If your eyes were sensitive enough to see them, the sky would reveal these streams as ghostly currents wrapping around the Milky Way and other galaxies in gossamer loops. They are the remnants of small galaxies and star clusters that strayed too close to a bigger galaxy and were gently torn apart. Over time, their stars spread out along their orbital paths, creating luminous trails that can stretch for tens of thousands of light years. In the Milky Way, astronomers have discovered multiple such streams encircling us, each one a lingering trace of a cosmic encounter from the past. They are like the faded ribbons of past dances, still floating in the galactic halo long after the partnering galaxy has been absorbed. One prominent example is the stream from the Sagittarius dwarf galaxy. As this small galaxy has been captured by the Milky Way's gravity, it's been stretched into a long filament of stars wrapping around our galaxy's center. Similar streams come from shredded star clusters or ancient dwarfs devoured eons ago. These stellar rivers are exceedingly faint against the blackness of space, but with modern surveys and telescopes, we can map them. They often appear as nearly linear sequences of stars. Some astronomers liken them to strings of pearls or tattered threads. Imagine a pearl necklace snapped and its beads laid out in a line. That's what a star stream can resemble. Each pearl is a star that once moved in a tight community, now dispersed along a common path. These streams tell a story. They whisper of how large galaxies like ours grow by gathering in smaller ones. The Milky Way's halo is effectively an archive of such meals, each stream a chapter in our galaxy's history, recording an event when a smaller stellar system merged and gave up its stars to the greater whole. But what orchestrates these gentle cosmic currents? The answer lies in something invisible, something that doesn't shine like stars do. Surrounding every galaxy, including our own, is an enormous halo of dark matter. Matter that neither emits nor reflects light, hence dark, yet it has gravity and mass. This dark matter halo extends well beyond the edge of the visible galaxy, forming a kind of massive, unseen sphere that envelops the stars. When a smaller galaxy ventures into this halo, the dark matter's gravity begins tugging at it even before the galaxy's stars feel the direct pull of the larger galaxy's visible mass. It's as if each galaxy carries a vast, invisible aura, and when those auras overlap, a slow tidal dance begins. The smaller galaxy is drawn out into a stream long before the cores of the galaxies meet. In this way, dark matter acts like a gentle current in the deep ocean, steering and shaping the flows of stars that result from these encounters. These interactions are subtle and gradual. Over hundreds of millions of years, the tiny galaxy's stars loosen and begin to trail behind it, like grains of sand slipping from a moving hand. As the stream forms, the pattern it traces is governed by gravity, not just from the visible stars, but predominantly from that dark halo. Occasionally, astronomers notice odd gaps or wobbles in a stellar stream, as if some stars are missing or have been knocked askew. These mysteries provide clues that something unseen, perhaps a clump of dark matter, like a submerged boulder in a river, perturbed the flow. In our minds, we can picture it. An invisible mass drifting through a stream of stars, scattering some of them and leaving a subtle gap. It's remarkable that we can detect the fingerprints of dark matter in this way, by observing the otherwise smooth stream of starlight and finding where it's been disturbed. It's like sensing an unseen presence by the pattern of ripples it leaves in a calm pond. Wherever we find a river of stars, we are also learning about the hidden architecture of a galaxy. The shape and orientation of these streams help us map out the contours of the dark matter halos. They show how far a galaxy's gravitational influence extends and how it is distributed. In the local group, the Milky Way and Andromeda both have extensive halos with perhaps tendrils that reach out toward each other. It's possible that the outskirts of our two halos are already touching, exchanging gravitational whispers long before the galaxies themselves will collide. If so, then the first greeting between the Milky Way and Andromeda has already occurred in these unseen currents, with star streams and diffuse gas responding to each other's pull. Contemplating these rivers of stars and the shadowy halos that guide them, you gain a new appreciation for the interconnectedness of our galactic neighborhood. What seems like empty space between the galaxies is actually full of structure. Faint stars, wisps of gas, and above all, the gravitational influence of dark matter shaping their arrangements. It is a very slow, graceful kind of motion, almost imperceptible on human timescales, yet over eons it creates these beautiful, tenuous links between worlds. There's a quiet harmony in it. As galaxies interact, They exchange material and influence each other, weaving the fabric of the cosmos ever so slightly tighter. Here, at this point in our journey, you find yourself marveling at how dynamic and alive our universe is, even in its most remote stretches. The galaxies are not isolated islands after all. They are connected through gravity and history, trading stars and encircled by halos of mystery. It evokes a sense of awe and perhaps a yearning, a pull on the human spirit to follow these threads outward and see where they lead. We have traced the map of our local group and sensed the flows of stars and unseen matter that bind it. Now, a question gently arises. Why do we feel this urge to explore further? Why are we drawn ever outward, to the point of imagining journeys to other galaxies? In the stillness of the cosmic night, we turn inward to reflect on the reasons for this deep-seated wanderlust, this cosmic curiosity that propels humanity forward into the unknown. Why do we reach out into the unknown? Lying here under the stars, you feel the stirrings of that question as old as humanity's first wanderings. There's something deep in us, a restlessness, a curiosity that has driven us across oceans and continents, up mountains and into the skies. That same impulse now points our gaze to the stars and galaxies. Part of it is pure wonder, the desire to see with our own eyes what is out there, to stand on a distant shore and look back toward home. When ancient sailors pushed their ships beyond the horizon, they didn't know what they would find, but they were compelled by the lure of discovery. Today, our ships are spacecraft, and our oceans are the spans between planets and stars. We go, or at least we dream of going, because we cannot help but wonder. The universe is vast and full of marvels, and the act of exploring it feels woven into our very nature. There is also a quieter, more pragmatic voice in us that speaks of the future. It reminds us that staying in one place forever might not be possible. Our Earth is precious, but it is one cradle among countless stars. The sun will not shine forever, and life's tenure on our home world is not guaranteed against cosmic time. To ensure that life, and what we value of humanity, endures, we may one day need to spread out among the stars. This isn't an immediate worry for today or tomorrow. It's a prospect for ages hence, far beyond our current horizon. Yet, the knowledge of it nudges us gently, even now. It instills a patient resolve to take the first steps, however small, towards becoming a spacefaring species. The journey to another galaxy might be millennia away or more, but every little advancement, every probe sent to a nearby star, every new technology that propels a spacecraft faster, is part of laying the groundwork. We plant trees so that our descendants might enjoy their shade. In the same way, we explore space, knowing that the full rewards may be reaped by generations to come. Beyond necessity or survival, we go because the act of exploration itself brings us joy and meaning. We are enchanted by the unknown. When we look at images of distant nebulae or the surface of Mars, or when we gaze at Andromeda through a telescope, we feel a thrill of connection. It's as if by learning about what lies beyond, we enrich our understanding of ourselves. There's a sense of belonging to something greater. Each discovery, a new exoplanet, the faint whisper of cosmic background radiation, or a new galaxy at the edge of the observable universe, is like adding a verse to a never-ending song. We listen, we learn, and we find beauty in that knowledge. The cosmos doesn't need us to observe it, but perhaps we need the cosmos. In observing it, we find perspective, we find humility, and we find inspiration. We also travel in our minds because it soothes our restless spirit. Humanity is a curious, questing species, and in many ways, this longing to explore acts as a lullaby for our collective soul. When we imagine setting foot on new worlds or reaching another galaxy, it comforts that part of us that always asks, what's next? The stories we create, of journeying through the stars, of meeting whatever might be out there, of overcoming the vast distances, are like gentle music. They play in our imaginations and ease the restlessness, giving it a direction and a dream. Just as a child finds comfort in a lullaby about far-off places, we find calm in envisioning our future among the stars. It tells us that there is a future, that there are chapters of the human story yet to be written, out in the starlight. That hope is deeply comforting. Our drive to explore is balanced by our patience. Space is unfathomably large, and the obstacles to crossing it are immense. But we take steady, measured steps. We built rockets to send humans to the moon, probes to the outer planets, and robotic explorers even beyond our solar system's edge. Each generation builds on the last, inventing better tools, asking new questions, and reaching a little farther. We know we won't see everything in our lifetimes, but that's all right. We are part of a grand continuum. As long as humans continue to look upward, there will always be new horizons. This patience in exploration is itself a kind of serenity. It means we can take our time, appreciate the journey, and allow ourselves to dream on a cosmic timescale. Lying under the sky now, you might feel a sense of unity with all those explorers of the past and future. Everyone who has ever yearned for the horizon shares a common bond. Whether that horizon was a distant island or another galaxy. Our voyages outward, in reality and in imagination, also bring us together back home. When we see Earth from space, we recognize how small and fragile it is, and how we all share this one world. In dreaming of other galaxies, we also recognize the preciousness of our own. The act of reaching out makes us cherish what we have, even as we seek what we do not yet know. And so we prepare ourselves, in spirit, if not yet in body, for journeys that may lie ahead. We fill our hearts with wonder and our minds with knowledge. We teach our children about the stars and what they might visit. We write stories and make plans, however tentative, to venture further. We stand on the shores of the cosmic ocean, eager to set sail. It's a gentle eagerness, patient and hopeful. Now, as our night's exploration comes full circle, we find ourselves at the edge of what we know, the boundary between our familiar cosmic neighborhood and the vast unknown beyond. In this quiet moment, we pause and gather up all the reasons we reach out: curiosity, hope, survival, and the sheer love of wandering. With these lights guiding us, we stand ready to take the next step, to cross the threshold into a new chapter of the journey whenever we are able. Let us hold that thought a moment, at the threshold of the galaxy, before we drift into the final gentle pause of our journey tonight. You find yourself standing at a threshold, not a physical one perhaps, but a boundary in understanding and imagination. In our journey tonight, we have floated from the gentle familiarity of a night on Earth to the far fringes of our galaxy. It's as if we have been carried to the very edge of the Milky Way's halo, that vast invisible sphere that marks the extent of our home galaxy's reach. Here, at this calm frontier, we pause. Behind us, we can envision the glorious sprawl of the Milky Way, its spiral arms and starry heart all laid out in a shimmering disk. Somewhere in that glow is everything we know: our sun, our planet, all the stars of our night sky, and the memories of our cosmic neighborhood. Ahead of us, before our feet, lies the dark of intergalactic space, beckoning with possibilities. Far in the distance, like a faint lighthouse on a remote shore, the Andromeda Galaxy shines, our next grand destination, still millions of light years away. The space between here and there is immense and silent, dotted perhaps with the sparse lights of a few stray stars or distant dwarfs. It is a gulf we have not yet crossed, a chapter of the story yet to be written. At this threshold, we linger in a moment of reflection. There is no rush. The silence out here is profound and soothing. We've come so far in our thoughts, from pondering light years to mapping our local group, from admiring our nearest galactic companions to tracing the faint streams of stars beyond. We carry all that insight with us now, like lanterns illuminating the dark. Standing on the edge of our galaxy's domain, you can feel both the gentle pull of home and the gentle pull of the unknown ahead. It's a bittersweet, beautiful balance, knowing how much we cherish the world and galaxy that made us, and also feeling the allure of the vast unexplored. Your mind's eye takes in the scene. Imagine turning back one more time to look at the Milky Way from this vantage. It might appear as a soft, glowing disk suspended in the void, tens of thousands of light years across, but now, from far out here, just a radiant oval in the blackness. Perhaps you can even make out the spiral structure, or the halo of globular clusters, like a sparse halo of fireflies around it. And somewhere on the fringe of that disk is a tiny star, our sun, far too faint to pick out, yet you know it's there, along with everything and everyone you've ever known. Such a view fills you with quiet awe. It's a reminder that home is both immense and tiny, depending on the perspective. Now you face forward into the darkness. The next steps, crossing the great intergalactic sea, remain ahead of us, to be imagined another time. For now, it is enough to stand here and breathe in the cosmic night, to feel the depth of the silence and the soft promise that it holds. Perhaps one day, humans, or our distant descendants, will actually make this journey, leaving the Milky Way and voyaging to another galaxy. They will become the sailors of the ultimate ocean, charting courses through the emptiness with our Milky Way receding behind them. In this moment, you can almost sense their future presence, like ghosts of tomorrow venturing out, guided by the same stars we have been admiring. The threshold where you stand is where their journey would begin. But tonight, our voyage is imaginative and inward. We have arrived at the edge of what we set out to explore for now. There is a tranquility in acknowledging that some distances will remain for future nights and future generations. The universe is vast, beyond our ability to fully traverse. But that's all right. It means we will never run out of wonders. There will always be something beyond, a new horizon to gently beckon when we are ready. So we stand here in silence, letting the stars and the darkness speak in their own way. It's a silence full of meaning, the culmination of all we've witnessed, and the expectant hush before whatever comes next. You might close your eyes for a moment and feel the infinity around you, not as something daunting, but as a calm, open space that welcomes your dreams. The boundary between what is known and unknown is a sacred, peaceful place. It's where we feel most alive with curiosity, yet also at peace with what we have seen. In this stillness, take a gentle breath. Above, the cosmos stretches on, and within you, there is a mirror of that cosmos, an endless capacity to wonder and imagine. We'll end our journey here for now, at this natural resting point. The stars slowly turn overhead, or perhaps underfoot if you imagine yourself floating in space. The Milky Way behind, Andromeda ahead, and you balanced at the brink, calm and unafraid. When you are ready, maybe on another night, you can always step over this threshold and continue the adventure, diving into the mysteries that lie beyond our galactic home. The universe will be waiting, as patient as ever, with its myriad galaxies twinkling in the distance. But for tonight, it's enough to have come this far. You carry the starlight within you now, a quiet glow of understanding and peace. Standing at the threshold of our galaxy, we have embraced both the comfort of home and the allure of the beyond. And in this balance, we find rest. In the silent expanse of space, a single beam of light bursts forth like a messenger on a mission. It moves at a blistering speed, fast enough to circle our entire planet 7 times in 1 second. This, the fastest thing in existence, seems almost infinite in its quickness. And yet, as it ventures beyond the familiar neighborhood of our solar system, that same beam begins to feel the weight of distance. What was once an instant now stretches into moments, then minutes, and far beyond, revealing how even light's swift pace becomes tenderly slow on the scale of galaxies. Imagine riding on this beam of light as it leaves the warmth of our sun. In just 8 gentle minutes, you would glide across the 150 million kilometers separating Earth from its star. In a few hours more, you drift past the outer planets, watching them shrink behind you. As you leave Pluto and the outer rim of our solar system, you glance back one final time. The sun, once so brilliant and dominant, has dwindled to a bright pinprick in an endless night. Days turn to weeks as you slip beyond the Kuiper belt and into the deep interstellar dark. At this incredible speed, the emptiness is still vast. Time passes, and distant stars inch closer only very gradually. Now the nearest neighbouring star, Proxima Centauri, lies ahead, a tiny beacon more than 4 light-years away. Even for our racing beam, that journey takes over 4 years of unbroken flight. 4 years to traverse a gap that, in the scale of our galaxy, is barely a step. The journey between stars is silent and mostly void, with only the faint glow of far-off suns to keep you company. Proxima itself grows from a mere speck into a gentle star ahead, but ever so slowly. You begin to sense how spacious the cosmos truly is. Each new target, each bright star or swirling nebula demands its toll in years or centuries of travel, even for a light beam that never grows tired. As our beam continues, it soon finds itself crossing the great gulf of the Milky Way. Our galaxy's disk, filled with billions of stars, spans over 100,000 light-years from end to end. Even at full light speed, to go from one side of this starry spiral to the other would require 100 millennia or more. The Milky Way's grand size reduces our swift beam to a patient wanderer. It drifts through the galactic night, passing clusters of stars and wisps of cosmic cloud, moving with purpose, but also with inevitable patience, surrounded by the soft glow of nebulae and the dense starry fields of the galactic core, the beam presses on through countless quiet nights. Beyond the edge of our galaxy, an even greater journey looms. The nearest large galaxy, Andromeda, waits more than 2 million light-years away. To reach it, our intrepid beam of light would need to travel for about 2.5 million years. Try to fathom that. A voyage so long that back home on Earth, entire species could rise and fall in the time it takes for our beam to arrive. From afar, Andromeda first appears as a faint smudge of light in the darkness. As the ages pass and you draw nearer, that smudge blossoms into a magnificent spiral, a swirling city of stars stretching out its arms. What felt like a furious sprint in the beginning has become a calm, unhurried odyssey. On galactic scales, light itself takes on a measured, almost leisurely gait. Even light's journey carries the weight of ages. When we gaze up at the Andromeda galaxy in the night sky, we are seeing it as it was 2.5 million years ago, because its glow has taken that long to reach our eyes. 2 million years is far longer than modern humans have walked the Earth. If we sent a greeting toward a galaxy so distant, generations upon generations would pass on Earth before any reply could return. Such distances turn even communication into an act of faith, underscoring how patience and long vision must guide any journey between galaxies. This realization is both humbling and strangely comforting. The universe has set a speed limit, and it is uncompromising. No material thing can outrun light, according to the laws of physics we know. Einstein's cosmic rulebook tells us that as we push faster and faster, nature pushes back, never letting us break that ultimate pace. No clever engineering or desperate yearning can cheat this fundamental barrier. So we accept that light's speed is the best we can ever do. And with that acceptance comes a certain peace. The stars will not be reached in a day or a year, and our journey beyond the Milky Way will demand extraordinary patience. Yet within this limitation lies a quiet wonder. Traveling at or near the speed of light, we are forced to experience the true vastness of space, moment by moment. It is a gentle reminder that the cosmos is not to be rushed through, but savoured. Each light year crossed is a triumph of time and persistence. Even the fastest possible voyage turns into a long, graceful crossing under the serene dome of the universe. In the end, fast and slow become relative terms out here, blending into a single profound truth. The journey to other galaxies will unfold on a timescale that invites reflection, humility, and awe. When we dream of venturing beyond our home galaxy, this is the first reality we encounter: the tremendous distance and the strict limit on how quickly we can traverse it. Light, our swiftest ally, becomes a fellow traveller that teaches us patience. With this understanding, we gently prepare ourselves for the road ahead. We turn our minds to the next subtle twist in this voyage: how time itself behaves when one moves through space at such incredible speeds. There is a secret softness to time that reveals itself when we move exceedingly fast. Picture time as a quiet river flowing steadily for all of us. Now imagine a starship that begins to rush along that river at nearly the speed of light. Around the speeding vessel, the flow of time itself grows gentle and slow. This is not something we feel or hear. It is a silent adjustment by the universe. As our ship hurtles faster, the clocks on board tick just a little more slowly compared to those left behind on Earth, as if time is offering the travellers a subtle, merciful pause. To the people on the ship, life seems normal. Their hearts beat at the usual rhythm, Conversations and laughter unfold as always, and their days pass in routine. But when they peer out the window, the outside universe appears to be on a different schedule. Imagine a crew setting out on a journey to a distant star, moving at some significant fraction of light speed. Suppose they travel out and back while their friends remain on Earth. Upon returning home, the crew finds that far more time has elapsed on Earth than they experienced on their voyage. They might have felt only a few years older, while their friends on Earth have aged decades. This gentle trick of time has made the long journey feel shorter for those aboard, even though the distance covered was immense. This scenario is often illustrated by the famous twin paradox. Imagine identical twins. One remains on Earth, while the other takes a near light-speed journey to a distant star and back. When the travelling twin returns, they might find their earthbound sibling has grown much older, perhaps having aged decades more. What sounds like a paradox is simply nature's quiet way of keeping time relative to motion. Each twin experienced the flow of time differently. This isn't merely a thought experiment. Even in today's world, astronauts and high-speed satellites experience minute time shifts due to their velocity and the weaker gravity above Earth. Over the course of a year, an astronaut might gain a few extra milliseconds of youth compared to those on the ground. These differences are tiny, but they prove that time dilation is real, so real that technologies like GPS must account for them to stay accurate. This strange phenomenon is known as time dilation, and it grows more pronounced the closer one travels to the speed of light. If our starship could somehow go faster and faster, approaching that ultimate speed limit, the effect would become dramatic. A trip that might seem to take centuries from an outside perspective could be compressed into only years or even months for the voyagers themselves. In principle, if one could travel near enough to light speed, even a journey to another galaxy might be experienced within a single human lifetime. The travelers would experience their days and nights normally, not realizing how extraordinary their speed is making their passage through time. Yet this gift from physics comes with a poignant consequence. While the voyagers perceive their trip as relatively brief, the rest of the universe continues its march without pause. The quiet river of time flows faster for everyone left at home. If our intergalactic travelers ever returned, they might find their homeworld changed beyond recognition by the millennia that have passed. In effect, these explorers would be time travelers to the future, skipping over ages as they journey. It is a bittersweet exchange. They gain the ability to cross unfathomable distances in their own short years, but they lose the synchrony with the people and places they left behind. On board the ship, none of this feels eerie or supernatural. The passengers still measure time in hours and days, celebrating birthdays and marking milestones as usual. It is only when comparing notes with the outside universe that the discrepancy becomes clear. Light speed travel stretches and bends the timeline in a delicate way, protecting the travelers from experiencing the full brunt of the eons that their voyage entails. In the solitude of their spacecraft, time is their gentle companion, shielding them from the vast ages unfolding elsewhere. Contemplating this interplay of motion and time, we find a small consolation for the enormous distances between galaxies. The faster we move, the more kindly time treats us on the journey itself. It is as if the universe offers a tiny loophole. You cannot break the speed of light, but you can ease the burden of years by riding close to that limit. However, to approach such tremendous speeds in the first place is no simple matter. It demands a staggering amount of energy and effort. As we appreciate time's quiet concession to the fast traveler, we must also face the practical challenge that lies ahead. The immense cost of accelerating a ship to these relativistic speeds and the energy required to sustain an intergalactic voyage. Every journey has a price, and for intergalactic travel, the price is measured in energy. To push a ship across the vast gulf between galaxies, we must pay in an almost unimaginable currency of power. Picture trying to launch a vessel to a fraction of light speed. The energy required isn't just a little more than we use today. It's millions, perhaps billions of times more. A single rocket burning its engines for a few minutes, as we do to reach orbit, is nowhere near enough. We are talking about sustaining propulsion for months or years, pouring continuous power into our voyage. It is like embarking not on a quick sprint, but on a marathon across a warm, endless ocean of energy. In our daily lives, we rarely encounter energy on such a tremendous scale. The electricity that lights our cities, or the fuel that propels our cars, is trivial compared to what a starship to another galaxy would consume. To get a sense of it, imagine harnessing the output of an entire power plant, not just for an hour or a day, but non-stop for decades, all dedicated to pushing one ship. Even that might fall short. We may have to gather the energy of a small star to accelerate a vessel to near light speeds. The numbers boggle the mind, but they underscore a simple truth. Leaving our galaxy will demand power on a level far beyond anything humanity has ever attempted. For perspective, accelerating even a single ton of mass to near light speed would consume energy equal to many years' worth of all human civilization's power output. It is as though to send one ship on its way, we must unleash power on the order of a small star, if only for a brief moment. Such figures defy easy comprehension. They underscore just how formidable this challenge truly is. Moreover, this energy cannot be delivered in one explosive burst. A sudden jolt strong enough to fling a spacecraft to near light speed would be both impractical and dangerous. The G-forces would crush any crew, and the ship itself might not survive the stress. Instead, the energy must be meted out gently and steadily, like a faithful tailwind that never lets up. Think of it as sailing across a vast sea. You need a constant breeze, not a single violent gust. In the cosmic ocean, our propulsion should be a continuous push, adding speed bit by bit in a smooth accumulation. Over weeks and months of steady acceleration, those small additions can build to tremendous velocities. This approach means reimagining how we fuel our journeys. Traditional rockets carry their energy on board as fuel and burn it quickly to achieve their speed. But for an intergalactic trek, carrying all the necessary fuel would make the ship enormously heavy, perhaps impossibly so. The more fuel you carry, the more fuel you need to lift that fuel, a dilemma that quickly spirals out of control. The solution is to find power sources that don't weigh us down. We might need to gather energy from our surroundings or beam it to the ship from afar, so the spacecraft can remain light and efficient. In other words, we will likely rely on external, abundant sources of power, drawing from the natural wellsprings of the cosmos rather than hauling all our energy with us. Envision a spacecraft slowly but persistently accelerating, its engines humming with a constant supply of power. Inside, the crew feels a gentle push, perhaps comparable to the pull of gravity on Earth, pressing them into their seats as the ship gains speed day by day. This comfortable acceleration could continue for months on end. After about a year of such steady thrust, the vessel would be racing at an appreciable fraction of light speed. The journey would no longer be a sudden leap, but a gradual, methodical climb to relativistic velocities. All the while, the ship would be bathing in a stream of energy, like a surfer riding an endless wave. To achieve this, we must figure out how to feed our starship with that constant, colossal power. Whether by harnessing the fire of nuclear reactions, the annihilation of matter and antimatter, or the radiant light of stars, we will need to become masters of energy. This power must be controlled and delivered with great care, maintaining the delicate balance of a long journey. It's clear that crossing the intergalactic void isn't just a navigation challenge, it's fundamentally an energy challenge. As we ponder this, one promising idea emerges. Perhaps instead of firing rockets, we can let light itself do the pushing. The concept of riding on beams of light, like a ship unfurling a sail to catch the wind, offers a graceful solution that transforms our energy problem into a dance with starlight. If rockets are the engines of the past, then sails might be the engines of the future. Not canvas sails filled with air, but delicate sheets of material pushed by light itself. Imagine a spacecraft unfurling an immense reflective sail in the void, like a gleaming kite catching the solar breeze. Photons streaming out from our sun bounce off that mirror-like fabric and impart a tiny push. It is almost imperceptible at first, a pressure so gentle that a person would not even feel it on their hand. But in the vacuum of space, free from any resistance, even this faint pressure can steadily accelerate a craft. Over time, that constant, silent push can send the vessel hurtling faster than any conventional rocket ever could. We already see hints of this phenomenon in nature. The tails of comets are swept by the light of the sun, and even tiny dust particles feel the sun's gentle pressure. Inspired by such examples, engineers have even tested the concept in space. A few years ago, a small spacecraft unfurled a shining sail about 20 meters wide and used it to navigate toward Venus, propelled solely by sunlight. This gentle experiment proved that photon pressure, however slight, can indeed move a craft. A thin reflective membrane spread out in space can steadily change a probe's path using nothing but the sun's rays. It moves without a roar or a plume of exhaust, gliding silently on rays of light. At first, its departure from Earth is almost leisurely, a few kilometers per second gained over weeks. But unlike a rocket that burns out and coasts, the sail continues to accelerate as long as light pours onto it. What begins as a crawl becomes a swift cruise, and then an outright sprint across the solar system, all powered by an invisible wind. The beauty of a light sail is in this dual nature, delicate in how it gathers momentum, yet relentless in the way it builds speed. Each photon's push is like a single snowflake landing on a pile, negligible on its own, but over time, snowflake after snowflake can form a mound. In the same way, billions of photons striking the sail every second add up, continuously nudging the craft faster. Months into its journey, a light sail ship could be racing at an incredible velocity, having never fired a single drop of fuel. There is a peaceful simplicity to this mode of travel. The spacecraft doesn't carry propellant or juggle complex engines. It merely opens its wings and lets the light carry it, much like a paper lantern riding a gentle breeze. For voyages beyond our solar system and towards other galaxies, sunlight alone may not suffice. As a sail-driven craft ventures far from the sun, the natural light grows weaker with distance. To keep accelerating, we imagine shining, powerful laser beams at the sail, like giving a distant sailboat an endless gust of wind whenever it starts to slow. By building immense lasers and focusing their beams onto the sail, we create an artificial solar breeze that can push the ship even when our sun is just a faint star behind it. The sail, perhaps kilometers wide and feather-light, would soak up the laser light and continue its forward dash. In effect, we turn starlight into a propulsion system, guiding our vessel with beams as straight and sure as an arrow. In fact, this notion is not merely science fiction. Even now, an international team of scientists is drawing up plans to use powerful laser beams to propel wafer-thin sails on journeys to nearby stars. Such projects show that humanity has already taken the first small steps toward making light sail travel a reality, one delicate craft at a time. From the perspective of anyone on board such a craft, the experience would be serene. They might not even sense the gentle acceleration aside from a slight pressure beneath their feet. The sail above would billow against the black sky, illuminated by the steady glow of lasers or sunlight. There is no vibration, no engine rumble, only the hush of space and the strange knowledge that an invisible hand of light is pushing you onward. In time, the ship would gather astonishing speed, gliding out of the solar system toward the stars, carried by the momentum of countless photons. Sailing on light is a concept that transforms our earlier worries about fuel and weight. By tapping into external light sources, whether the sun or human-made lasers, we eliminate the need to carry monstrous quantities of fuel. The challenge, however, lies in providing enough light to make the journey to another galaxy feasible. A lone sail in space needs a powerful beacon behind it, a sustained, bright source shining upon it across trillions of kilometers. Creating and maintaining such a luminous push will require us to build our own artificial suns, in effect, and so we turn our attention to those potential beacons, the great engines of light and energy we might construct, the hearths of power that could launch our gentle light sail craft across the intergalactic sea. The idea of harnessing light for propulsion leads us to envision monumental sources of that light, built by human hands. If a light sail is our ship's wing, then we must construct the torch that pushes it along. Enter the concept of the Dyson swarm, a multitude of satellites or mirrors orbiting the sun, collectively capturing a significant portion of its energy. Picture countless glimmering panels arrayed around our star, like a sparkling cloud, each one sipping sunlight and converting it into usable power. This is not a single giant structure, but a swarm of energy collectors, patiently assembled over years. Their purpose? To feed colossal lasers or microwave beams that will act as the engines for our outbound ships. These installations would be humanity's great hearths of power, mighty furnaces burning with captured starlight, tended carefully to launch our travelers into the dark. Building such a megastructure would be an epic undertaking, possibly the work of generations. It would demand materials on an astronomical scale, perhaps requiring us to mine entire asteroids for metal and minerals. Bit by bit, those resources would be transformed into millions of orbiting stations, mirrors, panels, and lasers, gradually forming a shell of technology around our sun. This could take centuries, or even millennia, of concerted effort. A slow construction project that no single generation would see completed. We start small, perhaps by constructing solar power stations near the sun, where sunlight is fiercest. Over time, more and more of these stations join the swarm, until the inner reaches of our solar system shimmer with their presence. From Earth, one might eventually see an artificial glow around the sun, the combined glint of innumerable mirrors and collectors. Each piece of the swarm adds to a reservoir of energy that far exceeds anything we have ever wielded before. Our sun produces more power each second than human civilization has used in its entire history. A Dyson swarm would let us tap into a fraction of that incredible output. It would be like gathering the wood and kindling for a bonfire on a cosmic scale, preparing for the moment we set it alight. With energy in hand, the next step is to direct it. This is where the beamer constellation comes in, an array of powerful lasers or transmitters, positioned perhaps on the fringes of the swarm or on dedicated stations, all aimed at the departing starship. Think of a circle of archers standing around a great fire, each drawing from its heat to shoot flaming arrows into the sky. Our archers are lasers, and their arrows are intense beams of light, converging on the light sail of the distant spacecraft. As the ship sets off, one laser after another locks onto its sail, keeping it bathed in a propulsive glow. When one beam falls out of optimal range or angle, another takes up the task, maintaining a continuous pressure on the sail over immense distances. In this way, a constellation of beamers works together, like a relay team of light, pushing the vessel ever faster outward. From the ground, or a safe station, operators would monitor these titanic beams, adjusting their focus and intensity. It's a delicate operation. Too little power, and the ship might not reach the desired speed. Too much could damage the sail. But with careful control, the sailcraft would gradually accelerate, fueled by the unwavering radiance from home. We can imagine the scene, a ghostly silhouette of a sail receding into the stars, visible only by the faint shimmer of the lasers trailing it. Back at the swarm, our artificial fires blaze steadily, their brightness directed with purpose and hope. Calling these power stations and beamers hearths evokes the right spirit. They are like campfires at the edge of our frontier. Just as ancient travelers depended on fires for warmth and guidance at night, our future starfarers will depend on these engineered fires to depart our cosmic shore. The hearths of power must burn continuously and reliably, tended by engineers and perhaps automated systems, ensuring that the beam never falters during a critical phase of the journey. It is a patient labor, maintaining a beacon that could shine for months or years to propel a single mission. But through such dedication, we extend our reach far beyond what lone rockets could achieve. The grandeur of a Dyson swarm and a beamer network demonstrates one path to the galaxies, building vast support systems that stay at home while our ships venture out. We turn our home star into a launch platform of unprecedented scale. However, not every plan for intergalactic travel relies on external push alone. Another vision beckons. Equip the ships themselves with engines so potent that they carry their own fire across the void. Before us lies the exploration of those possibilities. The fusion drives, antimatter engines, and perhaps even stranger technologies that could blaze a trail to the stars all on their own. Instead of relying on external beams or sails, we could carry our propulsion within the starship itself, a self-contained fire to drive us onward. This idea conjures images of harnessing the most intense energies known. One option often discussed is fusion power. Fusion is the process that makes stars shine. Light atoms like hydrogen merge into heavier ones, releasing tremendous energy in the process. In essence, a fusion rocket would be like bringing a small star along for the ride. Inside a reinforced chamber, plasma hotter than the core of the sun would be created, and its fiery exhaust would be directed out the back of the ship to produce thrust. It's a daunting task, to build a miniature sun and keep it caged just enough to propel a spacecraft. But if achieved, the payoff is enormous. A fusion engine's fuel, perhaps isotopes of hydrogen, contains millions of times more energy per kilogram than chemical rocket fuel. The flame of a fusion drive would burn bright and steady, pushing a starship with far greater power than any conventional engine we know today. Fusion propulsion has been imagined in various ways. Some designs envision pulses of fusion explosions, igniting small pellets of fuel in rapid succession to create a series of controlled mini starbursts. Others imagine a continuous fusion burn, a shining torch at the stern of the craft, fed by streams of hydrogen scooped from space. In either case, the visuals are awe-inspiring. A spacecraft flying on the back of a star, its exhaust a glowing trail of plasma. Unlike a delicate light sail, this method is raw and forceful. The ship carries its own furnace, its own sun, using the fabric of the universe, the fusion of atoms to propel itself. It's as if we take the sun's power and bottle it for our journey. While no such engine exists yet, ongoing research into fusion energy on Earth brings hope that one day this starfire could be controlled and directed for space travel. Even more potent than fusion would be an antimatter engine. Antimatter is the mirror opposite of normal matter. When the two meet, they annihilate each other completely, releasing energy far beyond even fusion's reach. An antimatter drive would use tiny amounts of this exotic fuel, perhaps grams or milligrams, to produce colossal bursts of power. Picture a spark, smaller than a grain of sand, capable of producing an explosion equivalent to tons of TNT. With antimatter, every ounce of mass is converted to pure energy. Following Einstein's famous equation, E equals mc, squared to its ultimate conclusion. Storing and handling such fuel requires extreme care, using magnetic fields to confine it so it never touches regular matter until intended. But if we could manage it, the result would be like harnessing bottled lightning. The spaceship's engine might release controlled flashes of annihilation, each one sending a pulse of thrust that far surpasses any chemical rocket blast. The idea sounds like science fiction, and indeed it remains firmly theoretical today, given the tiny quantities of antimatter we can currently produce. Yet it stands as a beacon of what physics allows, a reminder that nature permits such tremendous energy, if only we can learn to wield it. Venturing further into the realm of speculation, some visions of starship engines border on the fantastical. One of the most intriguing is the concept of a black hole drive. The thought is to create or capture a minuscule black hole, perhaps only a few millimeters or less across, and use its energy emissions to propel a craft. A black hole might sound like a dangerous thing to bring on board, but a tiny one would evaporate via Hawking radiation, emitting a flood of particles and light as it slowly loses mass. In effect, it would act like an extraordinarily powerful reactor. The ship could encase this micro black hole in a powerful magnetic chamber, directing the outflow of energy for thrust. The black hole would murmur in the form of heat and radiation, a whisper of creation's most extreme power, harnessed to drive our voyage. This idea is incredibly advanced and speculative. It requires technologies and understanding far beyond our current reach, but it illustrates the lengths to which we might go. If we can't find fuel in familiar places, we turn to the universe's strangest corners, trying to tame even a black hole for our purposes. Comparing these engine concepts, we see a spectrum from the merely difficult to the currently inconceivable. Fusion, while challenging, is something scientists around the world are actively working on for energy production. It feels like a matter of time and engineering before a fusion rocket could become reality. Antimatter pushes further, demanding capabilities we have yet to develop in producing and storing enough of this elusive substance. And the black hole drive, at least for now, lives purely in the imagination, a thought experiment about how far physics might allow us to go. What unites them all is the theme of unleashing vast amounts of energy from relatively little mass, embodying the efficiency we will need for interstellar and intergalactic journeys. Each of these engines of fire has its allure. The fusion drive offers endurance, a long, sustained burn, like the steady glow of a star, carrying a ship steadily across decades. The antimatter engine offers intensity, incredible power in short bursts, akin to a flash of lightning propelling the craft in leaps. The black hole drive, in its hypothetical glory, offers the ultimate in power density, a tiny object with the energy output of perhaps entire power plants, humming quietly in the dark. Armed with any of these, a starship would no longer be at the mercy of sunlight or distant lasers. It would blaze its own trail. However, even these mighty engines cannot break the fundamental rule we discussed earlier. The speed of light still stands as a limit. No matter how powerful the push, the ship would approach, but never exceed that cosmic speedometer. And so, in hushed tones, scientists and dreamers discuss whether there might be loopholes in the fabric of space-time itself, ways to travel not by brute force, but by bending the rules of reality. It is to these whispers of the exotic that we now turn, treading into ideas that feel like magic, yet emerge from the edges of physics theory. Around campfires of theoretical physics, there are whispered tales of possible escapes from the tyranny of light speed. Warp drives and wormholes have long been staples of science fiction, depicting starships zipping across the cosmos in the blink of an eye. In our reality, however, they remain speculative whispers at best, perched at the very edge of physics as we know it. These are not engines or fuels, but rather subtle tricks with space and time themselves. The two most enchanting ideas are warp drives and wormholes. They exist at the very edge of science, more speculation than reality, yet they captivate our imagination. In hushed, hopeful tones, scientists describe what they promise. The ability to cross cosmic distances faster than light would normally allow, as if by magic. But they also speak of what these concepts withhold from us, the extreme requirements and unresolved mysteries that keep them in the realm of whispers. A warp drive, in theory, would let a ship ride a wave of distorted space. Instead of moving through space faster than light, which we know no object can do, the warp idea is to make space itself do the work. Space is not an absolute rigid stage. It can stretch and curve. In fact, distant galaxies recede from us because space between us expands. If a starship could create a kind of bubble where space is compressed in front of it and expanded behind it, the ship could be carried along as space itself moves. Picture a surfer gliding on an ocean wave. The surfer isn't speeding on their own. It's the wave carrying them swiftly to shore. Similarly, a warp bubble would carry a craft forward, potentially faster than light relative to distant observers, without the craft locally breaking the speed limit. Inside the bubble, everything might feel normal. The crew could sip tea while space outside warps furiously. The promise here is staggering. It suggests a journey to a neighbouring galaxy might be accomplished in weeks or months instead of eons. The whisper of hope is that perhaps the universe's expansion and contraction can be tamed for our travel. Yet, the details of this concept are elusive. Early calculations for a warp drive implied it would require forms of energy and matter that we have never seen. Exotic matter with negative energy density, something that only appears in tiny quantum effects. The amount of energy, too, was mind-boggling. Initial estimates suggested needing more energy than exists in entire planets or stars, though later refinements have reduced these figures somewhat. Still, no prototype or experiment has ever come close to creating a warp effect. For now, warp drives remain a tantalizing equation on paper, a gentle rumor that maybe, just maybe, the cosmos has a loophole if we can figure out how to step through it. Wormholes present another alluring path. Imagine space as a great sheet of paper with two distant points, say, the Milky Way and the Andromeda Galaxy, marked far apart on the sheet. Normally, a traveller must cross the expanse between those two marks. But if one could fold that paper so the points touched, then punch a hole through, the traveller could hop from one point to the other almost instantaneously. That's the idea of a wormhole, a shortcut through the fabric of space-time, a tunnel that connects two far-flung regions of the universe. In fiction, wormholes are often depicted as stable, glowing portals. Step in one end and emerge light years away through the other. They promise truly miraculous voyages. You could leave our galaxy and pop out in another, bypassing the space in between entirely, as effortlessly as walking through a door. The physics of wormholes comes from solutions to Einstein's equations of general relativity, so they're not pure fantasy, at least mathematically. However, just because an equation allows something doesn't mean nature provides it for free. A traversable wormhole would likely also require that same mysterious negative energy to hold it open. Without some force propping it apart, a wormhole would pinch closed the instant anything tries to pass through, like a soap bubble snapping shut. To date, we have no evidence that usable wormholes exist in the universe. They might exist at microscopic scales or for fleeting moments, but a stable, human-sized tunnel across space remains speculative. There is also the matter of control. Even if one formed naturally, how would we find it, aim it to where we want to go, or ensure it doesn't vanish at the wrong moment? These questions remain unanswered. Warp bubbles and wormholes are, at this moment, akin to a quiet melody heard from a far-off land, enticing, but beyond our reach. They remind us that the laws of physics, as rigid as they seem, have corners we do not fully understand. Perhaps one day, a breakthrough will turn these whispers into a real voice. We might discover a new form of matter or a quirk of space-time that makes the impossible possible. But until then, we prepare to work within the boundaries we know. The dream of beating light speed is not yet a tool we can use. It lives in imagination and theory. As we return from these flights of fancy to the realm of the practical, we find there are still clever ways to stretch our capabilities. Even without warping space or opening magic doorways, we can navigate the cosmos by using the natural structures and forces already out there. In the halo of our galaxy and beyond, gravitational fields and cosmic currents offer subtle pathways, quiet lanes through the darkness that might ease our journey out of the galaxy. Our galaxy does not intend to let us go easily. Its gravity holds us like a gentle giant's embrace. But there are clever ways to slip out of that embrace by using nature's own forces to our advantage. One such method is the gravitational assist, a technique we already use for interplanetary probes. Just as a spacecraft can steal a bit of energy from a planet like Jupiter to slingshot onward, a starship might steal energy from something far mightier. Imagine plotting a course that dives deep toward a massive object, say the galactic core's supermassive black hole or a rapidly orbiting neutron star, and then veers away at just the right moment. The spacecraft would be flung outward by the encounter, like a stone from a sling, carrying away some of the massive object's orbital energy. Even in our time, spacecraft like the Voyagers have used such slingshot maneuvers around Jupiter and Saturn to gain the speed needed to escape the Sun's grasp. Those gravity assists helped Voyager 1 become the first human-made object to enter interstellar space, proving the value of this technique on a smaller scale. It's a daring maneuver, the cosmic equivalent of grabbing a speeding train to accelerate yourself. In theory, if executed precisely, a series of such assists could gradually build up a probe's speed without expending much fuel. The galaxy provides the push. We simply navigate the turns. Hypervelocity stars serve as proof that gravity can indeed impart tremendous speeds. These are stars observed racing out of our galaxy at breakneck velocity, some moving faster than 1,000 kilometers per second. Many are thought to have been accelerated by close encounters with the black hole at the Milky Way's center. Gravity's wild sling at work. A spaceship could attempt a similar path. By approaching the central black hole along a carefully calculated trajectory, it might gain an extraordinary boost. Of course, such a journey skirts danger. Come too close, and the ship would be pulled in, not flung out. But if our descendants master navigation well enough, they could dance with the giants of gravity and use them as launch pads to the intergalactic void. Beyond individual slingshot maneuvers, we can also look at the grand architecture of the cosmos for guidance. Our Milky Way is not isolated. It interacts with companion galaxies, and these gravitational interactions create bridges of stars and gas between worlds. When a dwarf galaxy passes near the Milky Way, tidal forces stretch it out, leaving streams of stars arcing through our galactic halo. These tidal bridges are like cosmic highways, chains of stars and clusters extending from one galaxy toward another. For example, the remnants of a small companion, the Sagittarius dwarf galaxy, have been stretched into a long stream of stars wrapping around our Milky Way like a luminous bridge, already pointing the way outward. One could imagine a future where explorers hop from one star to the next along such a stream, treating each star system as a way station. Like island hopping across the ocean, this would break a gigantic journey into a series of smaller steps. Each island is a star where a ship might resupply or simply mark progress, and the tidal stream itself provides a guide, a path already laid out by nature from here to there. Even travelling through the halo itself, the vast, sparse region surrounding our galaxy's disk, could be seen as finding a quiet lane. The disk of the Milky Way is crowded with stars, nebulae, and gravity wells that could impede or deflect a craft. But if a starship heads out above the plane of the galaxy, into the relative calm of the halo, it might avoid many of those obstacles. In the halo, the gravitational pull gradually weakens without constant perturbation from nearby stars. It's akin to climbing above the turbulence of the atmosphere into smooth air. The journey might become a bit easier once you're out of the busiest part of the galaxy's gravitational field. From that lofty vantage, the ship can set its course for intergalactic space with fewer distractions, following a gentler gradient of gravitational influence. All these strategies, gravitational assists, following hypervelocity trajectories, and cruising along tidal star streams, paint a picture of intergalactic travel that leverages the universe's existing structure. We become navigators, not just in space, but within the gravitational landscape, finding pathways that minimize the work we need to do. It is a patient and observant approach, much like ancient seafarers studied winds and currents. We will study the mass distribution of stars and galaxies to chart our routes. In the darkness of the halo, our ship might feel like it's drifting along a quiet cosmic road, guided by the faint pull of distant masses and the map of the galaxies drawn by their interactions. It's a reminder that even without breaking the known laws of physics, intelligence and ingenuity can open doorways to the impossible. With enough creativity, the galaxy itself offers us a hand, pointing out natural exits from our stellar metropolis into the greater universe beyond. One can almost picture a lone starship gliding along such a route through the halo, the dense Milky Way falling away behind it like a glittering veil. And ahead, only the sparse darkness of intergalactic space, dotted with the faint glimmers of other galaxies. It would be a quiet, profound crossing into the unknown. Now, as we step back and survey all these possible routes and aids, from light sails pushed by beams, to engines powered by fusion or antimatter, to slingshot catapults and cosmic bridges, one thing becomes clear. We are not without options. The road beyond the Milky Way may be long and challenging, but it is navigable in theory. The next question becomes which path to take first, and how to begin the journey. We stand at a crossroads of ideas, each with its own appeal and difficulties. Standing before this array of possibilities, humanity finds itself in a position both exciting and daunting. We have solar sails, whispering of graceful journeys, gigantic laser beacons, promising to push those sails, engines that mimic stars and conjure lightning, and even the tantalizing dream of bending space itself. Each approach has its wonders and its challenges. Some are nearer term, almost within our grasp. Others dwell in the far realms of conjecture. The question naturally arises, which path do we choose first, and how do we begin our journey beyond the Milky Way? It will likely demand not only our ingenuity, but also a unity of purpose, the cooperation of many nations and generations, all working together to reach the stars. Practicality suggests we start with what we can achieve with current or near-future technology. A likely candidate for the first interstellar steps, and eventually intergalactic precursors, is the light sail propelled by powerful lasers. Even now, engineers and scientists are designing wafer-thin probes that could be hurled to nearby stars on beams of light. Scaling that concept up to larger craft and longer distances will take time, but it provides a relatively concrete starting point. We could launch small messengers into the void long before a crewed starship is ready, testing the waters of the interstellar sea. These early sails would teach us how to aim lasers across unimaginable distances and how to communicate with something moving at a significant fraction of light speed. In choosing the light sail route first, we opt for something achievable step by step, a gradual expansion of our reach. On the other hand, the allure of a self-powered starship remains strong. Developing a fusion engine might take longer, but it offers flexibility and speed for larger vessels. It could carry explorers without the need for an infrastructure of lasers spanning light years behind them. Some argue that working on fusion propulsion, or even on antimatter production techniques, is a more direct path to crewed intergalactic travel. Indeed, progress in fusion energy might pay off on Earth as well, solving our terrestrial energy needs while paving the way for the stars. The first fusion-driven probes might only reach nearby star systems, but each success would build confidence to push further. When a fusion ship one day departs Earth's vicinity under its own power, steadily accelerating toward the blackness, we will have taken a decisive step on one of the paths we imagined. It is also possible that our first crewed journeys beyond the Milky Way will not rely on extreme speed at all, but on extreme patience. Rather than waiting for near-light drives, we might build a generation ship, a self-contained world where multiple generations of humans live and die during the voyage. In such a vessel, children would be born and grow old knowing only the ship as their home, and their descendants, many years later, would be the ones to finally reach another galaxy. Alternatively, future advances could allow crews to enter deep hibernation or suspended animation, sleeping through an eons-long crossing and awakening in a new galactic realm. These approaches would not shorten the journey's duration, but they would extend human endurance to match the cosmos, turning the voyage itself into a slowly unfolding chapter of our civilization. It's also possible that our journey will not rely on just one method. The most prudent plan may combine multiple techniques. Perhaps a spacecraft could be accelerated initially by a laser array, then switch to its onboard fusion engines for mid-journey maneuvers. It might use a close pass by a massive planet or star to gain an extra boost, even as it carries its own fuel. We might erect power stations in the solar system to assist launches, while still equipping ships with advanced engines for when they travel beyond the reach of any beams. In this way, Choosing a path is not necessarily a single decision. We are more likely to weave a tapestry of technologies, each supporting the other. Our first intergalactic craft might very well be a hybrid of many ideas discussed, the product of centuries of incremental progress and integration. And then there are the wild cards, the exotic possibilities that could, in one breakthrough, change everything. Should someone figure out how to create a stable warp bubble or a traversable wormhole, the conversation would shift dramatically. What once seemed like an arduous multi-million-year voyage could turn into something comparatively swift. Because these exotic options are so uncertain, we cannot bank on them, yet we also cannot dismiss them. Research continues on a small scale. Thought experiments in equations and tabletop experiments probing the quantum nature of spacetime. If a door cracks open in the wall of physics, we will be ready to step through. Until then, we walk along the wall, finding where we might climb over with the tools we have. In the end, the path we take will depend on what we value and what we are willing to invest in. Do we prioritize sending probes soon, even if they are tiny and uncrewed, to claim the honor of the first crossing? Or do we focus on building the capacity for humans to follow, even if it takes much longer to realize? Perhaps the answer is both. A flutter of small sails making the initial forays, followed by grander ships carrying the legacy of Earth to new skies. There is poetry in the idea that multiple strategies could be pursued in parallel, each enriching our knowledge of the cosmos in different ways. For now, as we stand at this threshold, all options remain on the table. No single approach has won out, and maybe that is for the best. The challenge is so vast that leaving every avenue open encourages creativity and resilience. What one path lacks, another can offer. What one generation fails to achieve, the next may conquer with a different technique. Humanity's journey to other galaxies is not a race with a single course, but a voyage of discovery, where the journey itself will likely involve many trials, errors, and triumphs along multiple fronts. Picture, in a distant future, looking up from a new world in another galaxy and seeing the Milky Way as a gentle band of light, a familiar glow now far behind. How we got there, whether by sail, engine, or shortcut, might matter less than the collective will that drove us to try every possible way. In preparing for that outcome, we live out the very essence of exploration, curiosity combined with ingenuity and courage. We don't know which approach will succeed first or succeed best, and that uncertainty is its own wonder. It means we still have so much to learn, to test, and to dream. As we continue this journey of exploration, we carry forward a sense of open possibility. Each concept we've explored is like a star in a constellation of hope, illuminating a path forward. The story of venturing beyond our galaxy is just beginning, and the decisions we make in the coming decades and centuries will shape that story. With patience and determination, we will chart our course among the stars, one gentle step at a time, beyond the Milky Way. In the remote reaches beyond the last planets, darkness nearly swallows all trace of human endeavor. Out here, the thick band of the Milky Way is a cold beacon overhead, and countless stars glint in eternal night. The sun is no more than a pale spark, offering only a ghost of warmth and light. It is in this silent dusk that our greatest workshop hums to life, hidden far from the glare and noise of the inner system. Spread among drifting ice and ancient rock, machines toil in slow, deliberate rhythms, forging the tools of a journey that will outlast generations. Giant crucibles glow with molten alloys, their faint light reflecting off icy crater walls. Robots move with unhurried grace, guiding liquid metal into molds that will become parts of an interstellar arc. In the vacuum and cold, each piece cools to hardness without haste, annealed by the eternal night. What forms here are colossal frames and delicate mechanisms alike, all destined to fit together into something greater, far away from any world. No atmosphere carries the clamour of construction here. Each weld and rivet is laid in total silence. The only sound, a faint vibration through metal and soot when humans occasionally venture near. The frigid vacuum is not an obstacle, but an asset, hardening alloys swiftly and keeping materials pure. A girder forged under these stars cools evenly with no warping, as if the void itself were an artisan tempering the steel. In this way, the darkness and cold that would be hostile to life become partners in creation, helping each structure emerge flawless and strong. Around these foundries drift the raw materials of creation, dormant comets rich with ice and ore, captured and harvested piece by piece. Automated miners bore into ancient rock and frozen methane, drawing out water for life support systems and metals for hulls and engines. In the feeble sunlight, solar collectors unfold like dark petals, but true energy comes from quiet reactors nested deep in each factory, providing steady warmth and power. The work goes on without fanfare or rest, year after slow year, as the components of our future ship take shape under careful, tireless supervision. There is no rush in this far-flung yard. Every motion is measured in hours and days instead of seconds. A girder, the length of a city street, is welded slowly along its seam, each spark a tiny star flaring and fading in the gloom. Months pass like quiet breaths as sections of hull and spindles for engines gradually come together. This cold, patient industry has a rhythm akin to a heartbeat slowed by sleep, one that will define the pace of humanity's boldest venture. When a component is finished, thruster tugs guide it gently through the void to a quiet assembly ground. In a wide orbit far beyond Neptune, pieces begin to merge. A spine of a ship extending here, a ring-shaped habitat connecting there. Each addition is an exercise in patience and precision, joining together with soft clicks and distant puffs of propellant. Over decades, the silhouette of a world ship emerges against the starry backdrop, a dark shape growing from a dream into reality. At such distance, even messages from home arrive with leisurely delay, linking human minds to these robot labourers by a tenuous thread. But mostly, the machines know their tasks by heart, carrying out plans laid down years before and updated as needed through that long electronic leash. In the darkness, they assemble the means to send it forth. Components of immense light beam projectors are crafted and quietly set into formation. Piece by piece, a human-made constellation takes shape out here, a lattice of devices that will one day shine their combined power into the void, heralding the start of an intergalactic journey. It is perhaps fitting that the seed of humanity's future is forged here, far from any cradle. In the emptiness, we have built with deliberate care, as if performing a ritual of creation. Every beam and panel carries the imprint of human perseverance, a belief that even in the coldest reaches, life can take root anew. By assembling this vessel in the dark, we declare that no frontier is too distant, and no night too long for the spark of human purpose. Drifting in far-off orbits, the beamers form a sparse constellation of their own, each a dark sentinel holding a reservoir of light. These stations hang in silence, separated by millions of miles, yet synchronized in purpose, all trained toward a single distant point where the world ship will be. For now, they bide their time, soaking up energy slowly from reactors or starlight, their systems quietly humming like creatures at rest. In the emptiness around them, nothing stirs but the faint glint of their mirrors catching the far sun as they wait for the moment to breathe power into the night. It took generations of dreaming and building to place these beacons out in the dark. Now they require no human hand at their controls. Each beam station operates in concert with its fellows, guided by the same quiet intelligence that built them. Their presence is a message in itself, a promise that we can reach across the void with light and intention. In the vast loneliness beyond Neptune, this lattice of machines stands as humanity's outstretched arm, ready to give the world ship the gentle push it needs to begin its voyage. At long last, the day comes when this web of beamers must awaken. In the darkness, a signal passes among them, unseen and silent, triggering each station to life. One after another, their laser assemblies stir from slumber, charging up with energy drawn from years of steady gathering. No explosive startles the void, only a growing radiance as invisible beams stretch outward, converging on a point still empty, but soon to be occupied by the vessel's great sail. In a way, these beamers are the wind makers for a new age of sail. Long ago, explorers waited for trade winds to carry their ships over Earth's oceans. Now we have forged our own winds from light. The great sail of the world ship will billow not with air, but with photons pressing steadily against it. It is a poetic inversion of old seafaring law. Instead of harnessing nature's breeze, we have created an artificial gust in the void, a gentle, constant push to send our vessel across the cosmic deep. Within each station, power has been amassing quietly. Years of charging and fueling have filled immense capacitors and primed laser banks. Now as they fire, the combined output rivals the brilliance of a small star, concentrated into pencil-thin shafts of light. And yet by the time this radiance reaches the world ship's sail, it feels like a persistent breeze, a pressure firm enough to propel, gentle enough to avoid harm. Across the void, each beam remains invisible to any onlooker, pure energy without a flame. Only tiny signs betray their passage, a speck of stray dust igniting here and there, a faint aurora flickering on a distant magnetic field. The beam stations themselves begin to glow gently as they work, heat radiators unfurling like glowing red petals to shed the excess energy. It is as if the constellation has taken a deep breath and now steadily exhales, a soft and continuous outpouring of force that pushes against the waiting sail. All across the outer system, these rays converge upon a single invisible target point. In that volume of space, a gentle radiance blooms where the beams intersect, forming a pathway of light. It is a corridor forged out of pure energy, ready to carry the ship beyond the last outposts of our sun. The Beamer constellation holds its breath in perfect synchrony, pouring power into the void and awaiting the arrival of the vessel to receive its gift. Now, at the focus of all these preparations, the world ship itself drifts in quiet readiness. From the outside, it is vast yet unassuming, a dark silhouette against the starlight, with a wide circular sail shimmering faintly at its front. Its form is not sleek like a rocket, but softly rounded and broad, designed for living rather than speed. This great vessel is a miniature world unto itself, a slow spinning arc with the gravity of home gently simulated within. Inside, the architecture feels more like a peaceful town nestled in a garden than a starship. Along the inner curve of a cylindrical habitat, fields and orchards stretch out under an artificial sky of soft lights. There are ponds with gently rippling water, and clusters of trees casting dappled shadows on walking paths. Day and night are imitated by lamps, brightening and dimming in rhythm, giving a sense of time to the quiet cycles of life on board. If one were to walk along the main habitat ring, the ground would curve gently upward ahead due to the ship's rotation. Looking farther down the path, you might see the fields and forests rising until they arch overhead, forming a continuous landscape above, an entire world on the inside of a cylinder. The sensation is both strange and comforting. There is a horizon in every direction, beneath a ceiling that is also a distant ground. Life carries on in calm cycles, making this artificial place feel uncannily like home. Along the gently curving walls are living quarters and communal halls designed for comfort and serenity. The cabins are small but warm, with windows that overlook the green landscapes or display the stars outside through digital screens. In these rooms, people will sleep and dream as the vessel carries them onward, each bed a cradle on an endless sea. Elsewhere, quiet chambers invite reflection, places to sit and listen to the hush of the ship's systems, to one's own thoughts, and to the faint vibration of eternity outside. Every element of this interior world is tuned for sustainability and peace. Hidden beneath the soil and behind the walls, quiet machines and circuits balance the temperature, water, and air, so subtly that life hardly notices their work. The gardens purify the air and refresh it with the scent of leaves and blossom, cycling water through babbling streams and misty evaporators. Sometimes a light rain is allowed to fall from the ceiling, nurturing the soil and creating a gentle patter that soothes as much as it waters. Aboard this drifting haven, one might hear the soft trill of a bird or the chorus of insects at dusk, subtle reminders of Earth echoing through the hushed pathways. This ship is a home and a garden, but it is also a chrysalis for its passengers. Within its halls lie all the necessities for a thriving community. Yet now, only a few caretakers wander the pathways, while others are at rest. Most of the voyagers have already tucked themselves into hibernation pods, or merged their minds with the ship's dreaming circuits, leaving the vessel populated by the gentleness of life in pause. The world ship drifts like a forest in winter, alive, well prepared and patient, carrying the promise of spring to a new world across the stars. Tucked away in secure vaults and gentle nurseries are the seeds and embryos of Earth's many living things, tiny libraries of DNA and spores rest in carefully controlled habitats, ensuring that the flora and fauna of a distant planet can one day mirror the richness of home. In essence, the world ship is more than a human abode. It is a traveling sanctuary for an entire ecosystem. From soil microbes to fruit tree seeds, from pollinating insects to preserved embryos of birds and mammals, a small Eden rides with the travelers, awaiting the moment it can awaken and bloom under an alien sky. In a hushed chamber deep within the ship, row upon row of hibernation pods glimmer faintly. Inside each capsule, a traveler sleeps in a near-frozen peace, heartbeats slowed to a crawl, breaths as light as morning mist. Faces are calm behind frosted glass, oblivious to the decades slipping by. These sleepers have entrusted themselves to time and technology, surrendering consciousness so that the long years ahead pass gently, like a single extended night. A dim blue light bathes the interior of each capsule, revealing the peaceful faces of those inside. They are held at the threshold of life, body temperatures lowered almost to freezing, heartbeats measured in minutes rather than seconds. A film of frost sometimes gathers at the edges of the pod's glass, melting away with each gentle warming cycle before forming anew. The automated systems tend to each sleeper with infinite care, circulating chilled fluids and tracking every faint vital sign. Thus, months and years slip by, unnoticed by the sleepers, their bodies preserved in a dreamless pause. Not everyone is completely lost in slumber. There are those who remain partly awake, living at a tempo in tune with the ship's slow journey. Perhaps one solitary soul walks the garden paths, while others dream, tending to small duties and watching over the sleepers. Their days might stretch leisurely over years, each action deliberate and unhurried. With lives extended by science and discipline, these caretakers experience time like a slowly turning page, ensuring that human eyes still occasionally witness the stars outside. From time to time, the ship's schedule calls for a brief awakening. Perhaps once every few decades, a handful of crew members are gently revived to inspect systems that the AI cannot physically tend, or to simply experience wakefulness. They step out of their pods into the softly lit corridors, their minds adjusting to the flow of time once more. These awakened souls walk through the sleeping gardens, perform maintenance rituals, and write down thoughts in the ship's journal, letters addressed to their still slumbering companions and to the future. For a short span, human laughter and voices echo quietly in the halls, and then, their tasks complete, they return to their long rest, yielding the ship back to silence. Elsewhere, in the quiet hum of the ship's central computer, other voyagers travel in a different manner. Their minds have been translated into patterns of data, freed from the limits of a mortal body. Some of them drift through virtual landscapes, sharing dreams of Earth or entirely new worlds conjured from imagination. Others simply rest as stored consciousness, waking only for brief moments over millennia, skipping through time like a stone on the surface of a vast, dark lake. Throughout the ship, silence and stillness reign. The air in the sleeping quarters barely moves, and the usual hustle of human life has been replaced by a kind of prolonged meditation. In this artificial night, the boundary between years blurs. A century can pass as softly as an hour. Every soul aboard is, in one way or another, dreaming, be it in biological sleep, slow mindful wakefulness, or digital reverie, and their collective dream carries them forward through the emptiness. While the travellers dream, the vessel itself remains vigilant. It cradles its sleeping passengers in safety, but outside its walls lies the infinite night with all its hidden hazards. Here in the quiet heart of the journey, human eyes may be closed, but the ship's protective systems are ever open. As the crew rests, unseen shields and deflectors stand guard against the dust and debris of interstellar space, ensuring that nothing interrupts this long repose. There is poetry in this method of travel. For generations we looked up and dreamed of reaching other stars. and now it is through literal dreaming that we strive to get there. In the stillness, time becomes fluid. A voyage that would terrify awake mortals with its sheer duration becomes manageable as a long sleep and a series of slow, thoughtful breaths. This suspension of life is a testament to hope, a willingness to close our eyes in the present so that we might open them in a future none of us have ever seen. Outside the cocoon of the ship, space is not truly empty. Tiny grains of dust and solitary atoms drift in the dark, remnants of ancient comets or distant stars. At the immense speeds of interstellar travel, even a particle smaller than a pebble could hit with catastrophic force. To protect the fragile life within, the world ship is wrapped in layers of gentle defences, soft in appearance, yet vital and strong. The foremost shield is a wide, sacrificial plate that rides ahead of the ship like a gentle prow. Made of resilient compounds and spaced well in front of the main hull, it takes the brunt of any collisions. When a micrometeoroid strikes, this outer layer vaporizes the impact or shatters into harmless fragments, sparing the inner sanctum from the blow. Behind it lies more shielding, successive thin films and empty gaps that together act as a cushion, turning what could be a fiery blast into a mere spark before it reaches the inhabited shell. Invisible lines of force also weave around the ship, forming a magnetic veil. This magnetic field extends like a protective aura, deflecting charged particles that stream through space. High-speed protons and electrons that might otherwise pierce the hull are nudged aside by this unseen shield, guided harmlessly around the vessel. At times, when these particles strike the magnetic bubble just right, they light up in gentle auroras that play across the darkness, a faint glow that signals the shield quietly doing its work. Beyond the solid shields and magnetic fields, the ship can even cloak itself in a halo of fine particles when needed, a kind of protective foam cast into its path. This cloud is scarcely detectable, a thin mist of ice crystals or tiny ceramic shards released ahead of the vessel. If a larger speck of cosmic debris approaches, it meets this mist first, colliding with the particles and losing much of its energy in a cascade of tiny impacts. By the time it reaches the core defenses, it has been ground into harmless dust or vapor, unable to harm the sleeping world within. These layers of protection function like the soft layers of an onion, giving way gently but effectively. What might have been a deadly strike is transformed into a brief flicker of light and a minor tremor that barely stirs the slumber inside. All the while, tiny maintenance drones creep along the hull, mending any scars and replenishing the foam with fresh particles. The Guardians are ceaseless in their vigil, forming a flexible armor around humanity's fragile hope as it glides through the dark. The philosophy behind these defenses is one of resilience through gentleness. Rather than brute steel plating alone, the world ship wears a wispy cloak of protections, more veil than armor, designed to cushion and deflect. It is a different kind of strength, flexible, adaptive, and enduring. In the face of the universe's random darts, this vessel trusts in patience and physics to guard it, turning potential fury into harmless light. Each grain of dust diverted, each particle absorbed, reaffirms that the fragile hope inside can survive the long night ahead. Guiding the ship through the featureless void is a task entrusted to minds that never tire. The navigation system listens to the cosmos itself for direction. The rhythmic flash of distant pulsars, the steady glow of far-off quasars, and the soft pull of gravity from known stars. These serve as beacons, like lighthouses for a ship at sea, giving the world ship a sense of place and bearing, even when no familiar planet is in sight. By measuring tiny differences in the timing of pulsar beats, the ship's computer can pinpoint its position in the vast darkness and adjust its course by the slightest degrees. At the heart of this guidance is an artificial intelligence, the tireless custodian of the voyage. While humans sleep, this digital caretaker tends to every system. It balances the ship's rotation, monitors the oxygen levels in the gardens, and keeps the reactors humming steadily. Thousands of sensors feed it data on the hull's integrity and the crew's vital signs, and with each passing second, it makes small corrections to maintain a perfect equilibrium. In the silence of the control decks, the AI carries out its duties calmly, like a vigilant gardener, ensuring every part of this traveling ecosystem remains healthy. This machine mind was entrusted with more than navigation and maintenance. It was given the quiet promises of the mission itself. It knows the hopes that launched this ship, the vow to deliver its passengers safely to a new sun, the commitment to keep alive the knowledge and dreams of Earth. These directives are encoded deeply in its core, guiding its every decision. In a way, the AI becomes the memory of humanity on this journey, recalling our purpose in moments when no one else can, and steering unerringly by those star-like ideals. To ensure such a vital mind never falters, it does not exist in only one place. Multiple redundant brains aboard the ship carry identical knowledge and watch each other's work, ready to take over in an instant if one should stray or fall silent. This overlapping vigilance means there is always a watcher watching the watchman, a perpetual cross-check that keeps the ship on course through the centuries. It is a quiet conversation of circuits and code, unfelt by any sleeper, but it underpins every safe mile of the voyage. As the ship's mind guides it forward, it also keeps an ear turned toward the faintest signals from afar. It listens for any sign from home, any echo of human voice crossing the void, and it prepares the ship to answer in kind. This vigilant listening and careful measuring of time and space ensure that the voyage stays connected, no matter how tenuous that link may become over the millennia. Through this patient exchange of whispers, the promise of communication with our distant past and future is kept alive. The relationship between the sleeping crew and their artificial caretaker is built on profound trust. Humanity has handed over its very survival to a machine mind, a creation now protecting its creators. In ages past, explorers relied on compasses and sextants. Now our compass is an AI that reads the heartbeat of dead stars. That progress is humbling. The crew dreams peacefully because they believe in the guidance of something we taught and then set free. A union of human purpose and machine precision, carrying the torch of life together through the darkness. In this voyage, communication becomes an act of faith. The distances are so great and the travel time so long that any message is like a bottle cast into a timeless sea. A simple greeting or status update from the ship takes centuries, even millennia, to reach back toward the old galaxy. By the time such a message arrives, those who first sent it will have long passed the torch to new generations, or the recipients may be the distant descendants of the original listeners. Yet the travellers still send out their letters into the dark, and those left behind still beam their own messages forward, trusting that someone, someday, will hear. In the beginning, a network of relay stations in the outer solar system helped boost the ship's voice, catching its signals and echoing them onward toward Earth. Likewise, Powerful transmitters on the world ship focus tight beams of information along its back trail, aimed where the solar system will be long after the ship has gone. Over time, the signals grow fainter and more stretched, but the ship continues to whisper its progress and thoughts to whoever might be listening in the ages to come. The messages themselves are crafted with the distant future in mind, knowing that those who read or hear them may not even be born when the words are sent. The travelers speak to an unknown audience across time. They send updates about the voyage, descriptions of the intergalactic night, and recordings of life on board. A garden tended under alien stars, a song sung in the echoing hall of the ship. These dispatches are part report, part diary, addressed to posterity. They paint a picture of humanity's journey so that one day, far in the future, others will know what it was like to sail between galaxies. Each transmission is also a comfort and a beacon for the travelers themselves. Even if no immediate reply comes, the act of sending a greeting or a story back toward home reminds them that they are part of a larger narrative. In the quiet of the ship, they imagine their message traveling year after year, eventually reaching human ears under a familiar sun. Perhaps those future ears will marvel at the courage of ancient ancestors. Or perhaps they will answer with their own tales sent forward, creating a bridge of words across millennia. In turn, the people of Earth sent their own voices into the dark, gifts for the travelers to carry. Before the distance grew too vast, a powerful transmission was dispatched laden with music, art, and words of encouragement. It contained recordings of ocean waves and birdsong, greetings in 100 languages, and images of sunsets and city lights, sounds and sights of a world the voyagers had left behind. This capsule of culture and comfort would follow the ship into the void, a last embrace from home to be remembered in the long silence. For now, each message that leaves the ship or arrives from the distant past is a thread connecting what has been to what will be. These threads stitch together the story of the journey, weaving the voyagers into the fabric of human history, even as they venture farther than any before. In the silence before departure, final words are exchanged and recorded, to be delivered across time. With all plans laid and farewells sent, the moment approaches when transmissions give way to action and the great crossing truly begins. There is a gentle defiance in these attempts to communicate. The voyagers know full well that the society they left will evolve or even vanish by the time their words return. They speak anyway, refusing to let their voice be lost to the void. In doing so, they accept that communication may become one way, transforming each message into a time capsule. Even if no answer comes, even if the senders and intended recipients are dust when the signal arrives, the echo of hello and hope will persist, traversing the stars long after its authors are gone. At last, the appointed launch window arrives, a serene moment in the dance of celestial mechanics. The great ship has been poised in readiness, waiting for this precise alignment when all forces are most favorable. The distant planets and the sun itself have arranged themselves just so, minimizing gravitational tugs that might distort the delicate initial path. In this calm, in the cosmic tide, the world ship and its array of helpers stand ready to breathe together and set the journey in motion. For a final few moments, everything is still. The beamers lie in wait across the darkness, their reactors humming at steady output, but their light not yet unleashed. Aboard the vessel, The handful of awake guardians, human or AI, run silent checks one more time, ensuring every system nods back with green lights. There is a sense of quiet anticipation, like the pause at the top of a deep breath, as all the machinery and all the hopes behind it synchronize for what comes next. Then, in unison, the gentle machinery exhales. One by one, the beamers ignite their invisible light, beams converging onto the reflective sail that now unfurls fully from the ship's front. Simultaneously, the world ship's own engines stir, if only at a fraction of their power, adding their push to the orchestrated effort. No flame or roar marks this departure. Instead, a gradual pressure begins to nudge the vessel, a soft and steady thrust that presses everyone and everything on board ever so lightly into their couches and cradle mounts. Slowly, almost imperceptibly at first, the world ship starts to move. The vast construction scaffolds and depots that surrounded it fall behind as the vessel slips forward along its calculated path. A gentle vibration resonates through the hull as it gains momentum, a far cry from the jostling of a rocket launch. This is more like a ship easing away from a quiet pier. In the control center, a subtle shift on the readouts confirms it. After years of preparation, they are finally leaving their starting harbor. On the bridge, the handful of awake souls watch readings and subtle star patterns with a mix of pride and poignancy. Through a small viewport, one can see the faint shimmer of the sail catching laser light and distant starlight, and the stars beginning to drift ever so slowly. There are no fireworks here, no cheers, just a quiet exchange of nods and perhaps a few moist eyes, knowing that something immense has begun. In that hushed control room, a murmured word of congratulations passes between crew members and then falls silent as they turn their eyes forward. A confirmation signal is sent back toward Earth, a brief flash of data, letting distant observers know we are on our way. Then the world ship turns its attention forward. Inch by inch, then meter by meter, it glides faster, guided by the unwavering beams and the pull of destiny. The launch is not a burst of fire, but a patient escape from home's grasp, so smooth and silent that it feels for a while like a dream, until the dream begins to gain the momentum of reality. Though unheralded by any grand ceremony, this is a defining moment in human history. Unseen by the masses and witnessed only by the few souls aboard and a handful of distant eyes, humanity quietly steps off its familiar shores. The era of living solely under the sun's dominion ends here, and a new chapter begins, one in which our home is not one star, but the galaxy at large. In the stillness of this launch, the species that once only dreamed of the heavens finally leaves its birthplace to wander among them. Across the gulf of space, on Earth and its outposts, a few dedicated souls monitor the departure. In a quiet control room, eyes well with tears as instruments confirm the world ship's gentle acceleration. They know that after this moment, the vessel will slip beyond human reach. A simple sign of success, a stable trajectory, a steady beam, prompts soft murmurs of celebration and a few embraces. A return signal is sent, carrying humanity's collective hopes and farewells, a final radio whisper chasing the departing ship into the dark. The acceleration continues, not in a sudden burst, but as a slow, steady dawn of motion. Hours fold into days, days into months, and the world ship incrementally gains speed. As the beamers persist in shining and the engines quietly toil, The feeling of movement grows from barely perceptible to undeniable. It is like watching a sunrise in the void. At first, there is only darkness and stillness, and then, gradually, light and motion seep in, gently but irrevocably. Before long, the ship is traveling faster than any human-made object ever has. The distant sun, already just a pale star, slowly diminishes further in its wake. Each day, the vessel sheds more of the pull of home, climbing outward with increasing confidence. Inside, most travelers remain asleep and feel nothing of the acceleration beyond perhaps a subtle change in the vibration underfoot. But the ship's instruments mark every milestone, every additional kilometre per second, every million kilometres traversed, with quiet satisfaction. On one occasion, as the ship glided through the outer fringe of the Oort cloud, it overtook a lone comet on its leisurely return toward the sun. For a time, the two travellers shared the same path. The comet's diffuse tail, a whisper of ice and dust, was illuminated by the distant sun and faintly by the ship's own lights. Those awake observed the ethereal visitor through external cameras, a final icy wanderer of the home system slowly falling behind as the world ship pressed onward. The encounter lasted only a short span before the comet was left to continue its ancient cycle alone, but it served as a gentle farewell from the solar system, a last companion at the threshold of interstellar space. In time, the world ship crosses the invisible frontier of the heliosphere, passing beyond the protective bubble of solar wind that envelops our system. There is no grand boundary to see, no sign saying you are now leaving home, but the data confirms it. The particles of the sun's breath grow thin, and true interstellar space begins. Not long after, it drifts through the outer fringe of the Oort cloud, scattering a few ancient comets with barely a ripple. Without fanfare, the ship leaves the sun's halo of debris and enters the gulf between the stars. From the vessel's vantage, the Milky Way's dense starry band still arches across one side of the sky, while the black of intergalactic space lies ahead. The home galaxy will gradually shrink behind them over ages. But for now, it remains a comforting glow at their backs. There is no immediate change in the silence or the routine on board. The transition is as gentle as every other aspect of this voyage. But a threshold has been crossed that can never be uncrossed. They are truly beyond the shores of their sun, sailing outward with nothing but infinite night before them. There is no grand celebration for this crossing. Perhaps a lone crew member awake at that time marks the occasion with a few keystrokes in the ship's log, or simply stands at a small window and whispers a private farewell to the sun. Then they too retreat into the background hum of routine. The journey continues, without fanfare or pause, the ship steadily accelerating into the unknown. As acceleration slowly gives way to a continuous cruise, the vessel's interior settles into a new normal. The beams from home will eventually cease, the engines will fall quiet, and coasting will begin. But the momentum gained will carry them onward for millennia. A gentle vibration remains, the hum of distance, a barely audible reminder of the journey's ongoing progress. With their planet of origin now just another point of light behind them, the travellers, sleeping and waking, human and AI, sail on, deeper into the dark, on course for the uncharted expanse ahead. Each passing day carries the ship further beyond any hope of return and closer to the unknown. By now, turning back would be as arduous as pressing on, a fact quietly noted by the AI and understood by the waking few. This journey is committed in full. Far ahead, the destination galaxy is still just a delicate smudge of light among millions, but with every kilometre gained, it grows imperceptibly brighter. In the millennia to come, that faint glow will expand into a new sky for the descendants of this voyage. For now, though, only the vast loneliness of interstellar space surrounds them, and the world ship presses on, faithful to its course. We have slipped into a darkness, deeper than any night on Earth, beyond the last reaches of our own Milky Way. In this vast gulf between galaxies, the familiar backdrop of countless stars has thinned to a scattering of the most distant pinpricks. One by one, those pinpricks grew fainter behind us, until we were left with a darkness so pure it feels almost untouched. Yet, even here, in a realm seemingly empty, there is a gentle presence that surrounds us. We drift through the intergalactic medium, a sparse sea of gas and dust spread thinly across the light years, like a faint breeze stirring an otherwise motionless expanse. Out here, the vacuum is near perfect, far emptier than any laboratory could recreate. And still, it is not absolute. A few stray atoms float in each cubic meter of space, remnants of ancient stars and galaxies, dispersed over unimaginable distances. On rare occasions, a lone hydrogen atom might brush against the hull of our ship, a solitary greeting from the thin between. The ship's instruments register these moments quietly, counting particles one by one. Evidence that even the void has a subtle texture. How empty can still be softly full? In this cosmic silence, fullness comes not from abundance, but from the persistent, ghostly presence of the nearly nothing at all. The intergalactic medium is like a faint sigh left over from the making of galaxies. It carries the echoes of creation, particles that never coalesced into stars, atoms cast away by cosmic winds, the ashes of long-dead suns scattered afar. We move through this tenuous material as gently as a swimmer through a calm midnight sea. There is no obvious resistance, no sensation of wind against our faces, but we know it's there. Over years and decades of travel, even a wisp of gas can impart a subtle pressure. It reminds us that we are not moving in pure emptiness, but through the thin breath between worlds. Sometimes we imagine this intergalactic space as a serene open ocean, and our ship as a lone sailboat. The void around us is the smooth, dark water, and the intergalactic medium is a calm breeze urging us onward. It's almost imperceptible, yet essential. Without any air, a sail cannot fill, and without any medium at all, we could not define motion. In the gentle push of this cosmic breeze, we feel both the enormity of the emptiness and the comfort that something of the universe still touches us here. Each particle is a tiny connection to everything else, a reminder that even between islands of stars, the space is not truly vacant. In this deep isolation, our senses adapt to notice the faintest hints of presence. The crew learns to find beauty in absence. We gaze into what appears at first as perfect black, and slowly our eyes and instruments pick up the subtlest glows and outlines, a delicate haze of distant starlight, the soft hue of nebulae millions of light years away, and the omnipresent background glow of the universe itself, all faint, all silent, yet all real. The thin between is empty enough to feel sacred, like a great cathedral of darkness, but it is laced with the gentlest whisper of matter and light, and in that we find a quiet companionship. Looking back, we can still faintly see our home galaxy as a delicate hazy disk, a ghostly panorama of billions of stars, now far behind. What was once the sprawling Milky Way sky, dense with constellations and clouds of light, has condensed into a pale, glinting silhouette in the distance. It drifts among the darkness, like an island we departed at dawn, already surrounded by the wide open sea. The sight stirs something complex within us, a blend of longing and liberation. We are unmoored from all familiar points of reference, yet carried by a purpose that draws us forward into the great unknown. Before we turned our sights completely forward, we took one last long look back at our Milky Way. The ship's cameras captured a panoramic view of our galaxy from the outside, a pale, elongated cloud of light, gradually shrinking with distance. For a moment, all of us paused to reflect on that image. Somewhere in that glowing whirlpool of stars was everything that had once been home. Earth, the sun, all our history. We held a brief ceremony of farewell, transmitting a final message of gratitude and hope back toward our distant galaxy, even knowing it would be millennia before it ever reached human ears. It was a gesture of closure, a way to honor where we came from as we stepped into the vast unknown. This nearly invisible medium around us holds secrets of the universe's missing matter. Astronomers once hunted for the lost atoms of creation, suspecting they lurked in the space between galaxies. Now we glide through that very space, confirming with each sensor reading that the void is a vast treasury of hidden substance. Though we encounter only a rare atom at a time, stretched out over millions of light years, these stray particles form enormous bridges and clouds. The intergalactic void is not a true void at all, but the gentle cradle of cosmic history, containing more in its tenuous grasp than all the stars of a galaxy combined. The character of this space is paradoxical. In some regions, the few atoms that linger here have been heated to millions of degrees by ancient supernova shockwaves and the energetic jets of quasars. Each particle carries the memory of violent events, yet so few and far between are these particles that their collective heat cannot warm a travelling ship. We pass through plasma that would register as searingly hot in a laboratory, but here it is spread so thin that it feels colder than the deepest winter. The thin between holds its warmth in spirit rather than touch, a reminder that extremes in the cosmos often coexist quietly. Unseen to our eyes, but mapped by our instruments, faint filaments of gas drift in this darkness, tying galaxies together in an immense cosmic web. Our journey may intersect one of these filaments, a subtle river of matter flowing between the Milky Way and Andromeda. If we could see it directly, it might appear as a translucent bridge, a highway for particles connecting one galactic realm to another. It comforts us to think that our ship is not entirely alone on the journey. There are natural threads already spanning the gulf, paths laid out by the universe itself, long before we dared to follow. Navigation in this starless expanse requires a new kind of compass. With no nearby sun to orient us and no familiar constellations, we turn to the galaxies themselves for guidance. Far ahead, the gentle glow of Andromeda serves as a distant lantern, our next destination faintly lighting the way. Behind us, the Milky Way's remnant shine acts as a guiding anchor, a reminder of where we came from. Together, these two galaxies, one ahead, one behind, provide a cosmic line of sight. We align our course along this line, much as ancient seafarers aligned their boats with the North Star. Only now, our North Star is an entire galaxy. All around, other galaxies punctuate the darkness as well, each one a tiny beacon if you know how to read it. Scattered spirals and ellipticals, some millions of light years farther out, form a sparse map in the void. We have charts aboard, that mark the positions of these far-off islands of light, and the ship's computer cross-references them with our view. By measuring angles between these galaxies, we can fix our orientation in space, the way earlier explorers used patterns of stars. Even the faintest smudge of a distant galaxy can serve as a landmark in the immensity. Each one we recognize brings a comfort. We are not lost. We are among familiar points on an invisible grid. Our journey is not just guided by external lights, but by an internal, steadfast rhythm. Deep within our vessel, gyroscopes and inertial guidance systems whir softly, keeping track of every slight twist and turn. They are like the steady heartbeats of the ship, ensuring we hold our bearing even when we pass through utter darkness. These instruments recall our last known trajectory and speed, updating constantly to prevent any drift from our chosen path. In the silence of intergalactic space, they provide a sense of stability, a continuous reference when visual cues fade away. Sometimes we cut all thrust and simply coast, conserving energy, letting inertia carry us across the light years. In those quiet periods, the sensation of movement fades. Without nearby objects, there's no visual parallax, no sense of speed at all. It feels as if we're perfectly still in a black ocean. But we trust the numbers. Our velocity measured in kilometers per second, our course plotted in 3 dimensions on glowing screens. The data tells us we are moving fast, faster than any human-made object before. Yet out here, speed loses its meaning. Distance and time stretch so vast that our swiftest motion becomes gradual. Wayfinding becomes an act of faith in our instruments and in the landmarks that change only slowly over years. We occasionally perform a celestial check-in. The ship's telescope will zoom in on a known distant galaxy or a quasar to refine our position. Like travelers pausing under a starry sky to confirm the constellations, we too pause to compare what we see with our stored star maps. We might find that our course has drifted a fraction of a degree, and then we make a gentle correction with the thrusters. These adjustments are small, but over millions of kilometers they keep us true. It's a humbling sight when the telescope shows us a swirl of billions of stars from across the universe, and we use it as merely a point in a navigation equation. Our tools have turned the entire cosmos into a grid for our voyage. The inertial frame we carry is precious. It's our private reference of up, down, and forward when external reality offers no hint. The ship's artificial gravity and floor beneath our feet give us a sense of what's down, but only the guidance systems know for sure how we're oriented relative to the universe. Sometimes a crew member will ask, "Which way is home right now?" And another will point roughly toward a wall, indicating the direction of the Milky Way, or gesture to the ceiling for Andromeda. These gestures are abstract in the emptiness, but they connect us to the idea that we still have a direction. We also take comfort in a cosmic stillness around us. With no friction or resistance, our path is exquisitely predictable. There are no currents to sweep us off course, no hidden shoals, only the faint gravitational pulls of unseen masses. Occasionally, the ship's trajectory is subtly altered by the gravity of something large and far away. A galaxy cluster, tens of millions of light years off, exerting a delicate tug. Our navigation accounts for such tiny influences, making minute tweaks so that over time these deviations do not accumulate. In effect, we sail on a perfectly calm sea, adjusting now and then for the gentle tides of gravity that reach even into emptiness. To travel between galaxies is to trust in guides that are themselves drifting in space. Andromeda moves too, coming toward us in a slow dance that will take billions of years to complete. The Milky Way, behind gradually recedes. Every reference point is in motion, yet relative to us, they seem fixed over our short lifetimes. This realization brings a philosophical peace. We navigate by lights that themselves journey through the cosmos, and in doing so, we join the grand choreography. Wayfinding by galaxies is not finding static signposts, but moving in concert with the cosmos, using its grandest structures as our compass points. Even with all this precision, there are moments when we simply rely on intuition and the awe of sight. Looking ahead through the viewport, the diffuse glow of Andromeda has grown slightly larger and brighter than when we began. It is still faint to the naked eye, but our cameras show its spiral arms in soft outline now, a lantern slowly swelling on our horizon. That gentle confirmation on the horizon of darkness can lift our spirits immeasurably. It tells us that, step by step, light year by light year, we are making progress. In the boundless dark, just the sight of our destination, inching nearer, is enough to keep hope vivid and directions clear. In the quiet of intergalactic space, where no star shines nearby, one might think the darkness is absolute and silent. But even here, there is a subtle light permeating every direction, a remnant glow from the universe's very beginning. It is invisible to our eyes, lying beyond the spectrum of visible light, yet our instruments can feel its presence like a gentle warmth. This is the cosmic background radiation, the faint afterglow of the Big Bang, still with us everywhere we go. In the emptiness, it is the color of silence, a uniform, soft whisper echoing through the cosmos, too quiet for human ears, but unmistakable to those who listen with the right tools. Long ago, when the universe was young, that whisper was a roar of light filling all of space. Over nearly 14 billion years, it has cooled and dimmed, stretching into microwave frequencies, a far cry from its once blazing glory. Now it bathes the spacecraft in a very gentle radiation that is nearly the same from all sides. We tune our sensors to it and detect a faint hiss, like the softest sigh imaginable. That hiss is ancient photons, as old as time, finally ending their long journey upon our detectors. To think, the very heat that once lit up the infant cosmos now simply lingers as a mere murmur around us. Our ship's instruments use this cosmic whisper as a guide and reference. By measuring it, we can tell if we are moving ever so slightly relative to the universe at large. A subtle warmth, coming more from one side of the sky than the other, tells us we have a motion in that direction. If we calibrate precisely, we could even adjust our velocity to sit almost still with respect to this primordial light, effectively drifting in the same calm current that has persisted since galaxies were newborn. In practice, we carry on toward Andromeda, but we note these variations in the background glow to refine our course and to test our sensors' accuracy. The cosmic background is like a benchmark, a steady, reliable light-filling space against which all other signals can be compared. This background radiation also provides comfort in its constancy. No matter how far we travel from home, the afterglow of the Big Bang surrounds us, unchanged. It's as if the universe itself speaks in a low voice that never ceases. On lonely nights, some of us imagine we can almost hear it, not in sound, but in our minds, a faint cosmic humming that reminds us of our connection to all that has ever been. It's the oldest light in existence, and it accompanies us like an old friend telling an ancient story over and over, just to let us know we are not alone in the dark. In truth, the cosmic background is a near-perfect uniform glow, but we sometimes think of it as having a colour beyond sight, a sepia tone of the universe's memory. Its warmth is only a few degrees above absolute zero, yet compared to the utter cold of space, it is a gentle heat. This tiny bit of warmth means that the universe has never gone completely dark and cold. There's always a low fire of creation's echo, smouldering everywhere. Even in the bleakest cold, a faint ember persists, reminding us that the cosmos still gently glows. Our voyage may feel unique and pioneering, but when we sense this omnipresent whisper, we are humbled by how small we are against time. The light that guides our instruments today is the same light that shone when there were no stars at all, when the first atoms were just forming. To travel beyond the Milky Way and hear this ancient echo is to step into deep time, to feel the past alive in the present silence. Sometimes, during routine checks, we point an antenna out into what appears to be empty blackness and listen. The data comes back as a gentle curve on a graph, the hallmark signature of the cosmic background. It is smooth and consistent, confirming that nothing nearby is interfering, no stray star or galaxy dominating our view. That smooth signal is oddly reassuring. It means we are truly in the quiet deep, away from any local noise, hearing the cosmos in its purest form. In that purity, we find a strange kind of companionship, as though the universe itself keeps us company with its faint afterglow. This ancient light has no voice, and yet it speaks to us. It tells us of a time when everything was hot and close together, before any journey like ours was conceivable. It reminds us that all the galaxies we navigate by came from one luminous fog eons ago. In moments when we feel small and alone, we think of those photons of the cosmic background, travelling for billions of years, only to brush against our ship. Their long voyage ends as ours continues. In the great silence between galaxies, that gentle meeting feels like a handshake with creation, a quiet reassurance that our path is part of a much larger story. Space may be silent out here, but it is not entirely safe. In the stillness lie invisible threats that demand our respect and vigilance. The vacuum between galaxies carries tiny bullets and ghostly rays that we must weather as we voyage. They are quiet hazards, not dramatic like roaring storms or towering waves, but persistent and patient. Over time, even a whisper of danger can accumulate if ignored. So we treat these hazards as a kind of cosmic weather, something to monitor, prepare for, and endure with care. One such hazard is the micrometeoroid, a minuscule fragment of rock or dust drifting in the dark at unimaginable speed. In intergalactic space, they are rarer than within galaxies, but they do exist. A pebble here, a grain there, left over from eons of cosmic events. Our ship's hull bears scars of their passing, tiny pits and craters where a speck of dust collided at tens of kilometers per second. Most are so small, we never notice them in the moment. Only later, when inspection drones scan the outer shields. It's akin to finding the occasional dent after a hailstorm, a silent ping in the night that we only confirm after the fact. To guard against these particles, we have layered shielding that encases our vessel like rings of armor. The outermost layer is designed to shatter and absorb micrometeoroids on impact, vaporizing them or slowing them down before they reach the main hull. Behind that, thicker plating and even a magnetic field stand ready to catch any charged fragments or plasma produced by the strike. Inside, we hardly ever feel a thing. The crew trusts that protection, but we also practice patience as a form of defense. When our long-range sensors detect a dense patch of dust or debris ahead, perhaps remnants of an ancient comet that strayed out here, or a trail of particles from a distant collision, we adjust our course or reduce our speed. Just as a sailor might steer clear of dark clouds on the horizon, we give potential hazard regions a wide berth if we can. Cosmic rays are another of these quiet dangers. They are high-energy particles, born in the violent hearts of stars and galaxies, that zip through space at nearly the speed of light. Unlike micrometeoroids, these rays cannot be seen or easily dodged. They permeate space constantly, arriving from all directions. Most pass through the ship and our bodies without a trace, leaving only faint ionization in their wake. Yet once in a while, one interacts in just the right way that we notice it. A crew member might even perceive a brief flash in the corner of their vision as a particularly energetic ray strikes the fluid of their eye, a fleeting reminder of this invisible rain. Over long periods, cosmic rays can damage our bodies, subtly altering DNA or weakening cells, much like unending, penetrating sunlight. Our ship is built to mitigate this. Walls lined with water tanks and special materials soak up radiation, and magnetic shields help deflect charged particles. These are our raincoats and umbrellas against a storm that has no clouds. In essence, we have turned our vessel into a moving sanctuary against this perpetual drizzle from deep space. There are times when cosmic ray levels rise unexpectedly, perhaps due to a distant supernova that we have no other way of knowing about. The detectors on board pick up a slight uptick in radiation, and protocols quietly engage. Non-essential systems may power down momentarily to avoid false readings or damage. The crew retreats towards shielded areas in the core of the ship, a bit like huddling by a fireplace during a cold night. We wait, monitoring the levels, knowing that eventually the surge will pass and we can move about more freely again. These moments are rarely frightening. They unfold slowly, giving us ample time to respond. In the stillness of space, even dangers announce themselves subtly if you are listening, and we have become skilled listeners. We also face the cumulative wear that space inflicts, which is a hazard in slow motion. The constant drizzle of radiation can make electronics age before their time, flipping bits in computers and gradually degrading sensors. Microscopic impacts sandblast the exterior over decades, as if the ship were a desert rock enduring eons of wind. Our engineers are always at work, checking circuits for glitches and sending out maintenance bots to replace eroded panels. Through steady diligence, we manage these problems before they ever threaten the mission. It's as routine as repainting a house after a long winter. Maintenance becomes a ritual that keeps danger small and far away. Calling these hazards weather shapes our mindset. We cannot eliminate cosmic rays or stray debris, just as one cannot stop the wind or the rain. Instead, we predict, shield, and adapt. The crew has learned not to dread these things, but to live with them. We compare notes on radiation levels like others might discuss the day's temperature, and we speak of micrometeorite forecasts when we chart our path. It's a practical language that turns unknown perils into something familiar and almost homey. By treating danger as weather, we remember that we have shelter and skill enough to get through the storm. Out here, a clear day is simply a day when nothing significant strikes us and the radiation stays low. Most days are clear, and for that, we are thankful. On those days, we can almost forget the risks and just enjoy the voyage. But even when the cosmic weather grows a bit rough, we remain calm. We have confidence in our vessel and in each other. We know that a sturdy ship and a prepared crew can handle the gales of emptiness. With patience and good design, we have turned a deadly environment into merely a challenging one. Each time we safely ride out a quiet hazard, it reinforces our sense that we are capable of living in this intergalactic wilderness, not invulnerable, but resilient, as any good travellers must be. Life aboard continues in cycles of work, watchfulness, and rest, year after year. In the beginning of our journey, we kept careful track of time by the calendars of old Earth, celebrating New Years as they came, counting each month and day. But as the years stretched on, something changed in our perception. With no rising or setting sun to mark the days, time became more fluid, blending softly into itself. The boundaries between one year and the next grew fuzzy, like threads woven into a single cloth. We still mark time, but gently. A birthday here, an anniversary there. Yet each is part of a continuous tapestry, rather than a page in a calendar. In the deep of intergalactic space, years become threads in a story we are endlessly weaving. Without a sun overhead, we had to create our own rhythm of day and night. The ship's lights and systems follow a cycle that simulates a 24-hour day, giving us mornings and evenings to anchor our routines. It was a deliberate choice, a nod to the world we came from, to keep our bodies and minds in a healthy cadence, waking up to a soft glow that brightens the corridors and winding down as the lights dim helps us feel the passage of days. Yet these are artificial days, and we know it. Sometimes a child born on the ship asks what a true sunrise looks like, and elders describe the way dawn light would spill over a horizon, a sight these children may never have seen with their own eyes. So we simulate even that, projecting golden hues at dawn in the observation bay, or painting sunsets on the walls with gentle colours, small efforts to remind us of the cycle that once guided all life. Seasons are another rhythm we have had to recreate. On Earth, the tilt of the planet and its orbit around the sun brought changing weather, the blossoming and withering of foliage, a sense of renewal and rest each year. Here, drifting in eternal night, one day is much like another, unless we make it otherwise. And so we do. In our hydroponic gardens, we simulate seasons for the plants. We adjust the temperature and light spectrum over long periods to mimic spring bloom and autumn harvest. The cherry trees in our arboretum lose their leaves in what we call October, and grain fields in the agricultural bay turn golden in our artificial summer. These seasonal rituals bring comfort and variety, giving the crew something to anticipate. They break the monotony with the pageant of life cycles, even if entirely orchestrated by us. In turn, tending to the seasons keeps us grounded. We celebrate planting and harvest festivals. We even have a winter where we exchange handmade gifts and gather in the warmest chamber to share stories. Traditions carried from Earth, kept alive out here, where no true winter or summer exists. Culture aboard the ship has blossomed in ways both familiar and completely new. Cut off from Earth's immediate influence, we have become our own small world. We have artists who compose music inspired by the hum of the engines and the silence outside. We have writers and poets who craft epics about the journey, love stories set in starship hallways, and comedies about the quirks of living in a metal bubble. Our children learn about Earth's great works, Shakespeare, Beethoven, the folk tales of countless cultures, but they also learn the new folklore of the voyage. They know the names of every major meteor shower we've weathered and can recite the tale of the great reactor fix when our engineers heroically solved a critical problem years ago. These narratives, old and new, bind us together. Through shared songs, stories, and art, we maintain a sense of identity. We are not just a crew executing a mission. We are a community, a tiny civilization in transit between galaxies. Rest and leisure have their place as sacred parts of our routine. Without a sun to signal the end of the workday, we might have driven ourselves too hard, lost in the endless tasks of maintenance and navigation. Instead, we instituted communal evenings. When the ship's lights dim to mimic twilight, many of us gather in the common rooms. We play games, some handed down through generations, like chess or card games, and others invented right here on the ship. We watch old films in a small theatre and laugh or cry together at stories from the home we left behind. There are dance nights where someone strums a guitar or plays a violin, instruments carried carefully from Earth, and couples sway as if under a sky of remembered stars. Such moments of joy and normalcy are as vital to the mission as fuel or oxygen. They remind us why we voyage, not just for the destination, but for the living done along the way. Over the years, we have become gardeners of memory and meaning. We tend to our recollections of Earth, making sure each new child knows of blue skies, green forests, and the smell of rain on soil. We nurture these memories through education, through virtual reality scenes that recreate earthly landscapes, and through the simple act of storytelling. Parents pass on childhood memories of their own to children who listen wide-eyed to tales of climbing trees or swimming in the sea. In a literal sense too, we garden. We cultivate plants brought from Earth, heirloom seeds that have travelled millions of miles. The hydroponic garden is one of the most beloved spaces on the ship. It's lush with familiar leaves and blooms, a small patch of Earth we carry with us. Crew members volunteer time there, not just for farming, but for therapy, pruning bonsai trees, smelling herbs like rosemary and mint, tending a pond with lily pads and fish. In caring for this living collection, we feel connected to the broader lineage of life. Gardening our memory means we also preserve the story of our journey itself. Each major event gets recorded and ritualized. Our departure day is commemorated annually as Founders' Day, and the day we officially left the Milky Way's boundary became a ship-wide holiday known as Crossing Day. People share their personal logs from those moments, recalling what they felt as our galaxy fell away behind us. By turning milestones into shared memories, we weave meaning into the long stretches of time. It's not just Earth's calendar we keep, but a new calendar of the voyage. This helps us feel progress and purpose, as the stars outside hardly change for generations. Our calendar of meaning, filled with anniversaries of our odyssey, gives shape to the years and reminds us that though we travel far from any sun, we still live by the light of shared experiences. As years turned into decades, and decades perhaps into centuries, continuity became something we cultivated actively. The crew that first left Earth made sure to instill the mission's purpose in their children, that reaching another galaxy is a dream worth generations of effort. Now those children are adults, and some have children of their own. The passage of time could have made the goal feel abstract. but through storytelling and education, each new generation takes up the mission as if it were their own idea. We've held naming ceremonies for newborns, where elders whisper blessings under projections of the Andromeda Galaxy on the ceiling, symbolically making the destination a part of the child's life from the start. And when a beloved member of our community passes away, even in the best of conditions, life ends. We hold memorials that tie their memory to the voyage. We might name a new module after them, or plant a tree in the arboretum in their honor. In this way, the meaning of the journey grows with us. Every life lived on the ship, every loss and every triumph becomes another reason to see things through, to carry our humanity safely to the next shore. Living without a sun overhead could have felt like eternal night, but instead, we have made it a space of constant, gentle illumination, lit by our creativity, our traditions, and our care for one another. We have proven that home is not a place on a planet, but something we build around us with community and memory. In the solitude between galaxies, we have seasons of the heart instead of seasons of the sun, and they sustain us. Each member of the voyage, past and present, is a thread, and together we weave a tapestry of purpose that carries us forward. In this way, our days and years, though unmoored from any sunrise, are rich with meaning and momentum. Time during the long drift between milestones is measured not in grand events, but in small, meaningful routines. In these quiet stretches, the voyage is kept by the hum of daily life. Crew members wake to gentle alarms, stretch, and exchange quiet greetings in the corridors. The morning might bring a familiar checklist: inspect the hydroponic gardens, calibrate a sensor, run a diagnostic on the water recyclers. Each task is ordinary, almost mundane, yet performing them gives shape to our day. There is comfort in the repetition. Just as sunrise and breakfast once anchored us on Earth, out here it's the morning reports and shared duties that begin our cycle anew. Through these simple routines, we find a sense of normalcy amid the extraordinary fact of where we are. Many of us keep journals or voyage notebooks, recording thoughts and observations that might otherwise slip away in the flow of time. In these pages, the small discoveries of a day find a home. A science officer notes a tiny fluctuation in background radiation and muses that perhaps a distant supernova caused it. An engineer sketches a new idea for improving the efficiency of a solar array, inspired by watching dust motes dance in a beam of lamplight. A gardener in the life support bay jots down the first bloom of a tomato plant seeded months ago, a bright red dot of life amid the green. None of these entries will change the course of the mission, but they capture moments of curiosity and wonder that pepper our long journey. Flipping through the ship's log or someone's personal diary reveals the texture of our voyage, not just the big leaps between stars, but the gentle, continuous journey of mind and heart. Each page forms a small but essential star in the tapestry of our journey. Small rituals have emerged that give each week a familiar rhythm. On Tuesdays, for example, a few of the crew gather in a quiet corner of the observation deck for what they call the stargazers' coffee. They sip from steaming mugs and stare out at the far-off galaxies or the featureless dark, sharing any new thoughts or simply enjoying a companionable silence. Friday evenings, after work, there's a brief ship-wide broadcast of music. One week it might be old jazz from Earth. Another week, a new composition by one of our onboard musicians. These little events become signposts in time, things to look forward to. They break up the long expanse of days, and give us cause to smile. We celebrate minor victories too. A month with no system glitches, a successfully repaired circuit, the finding of an interesting comet trail in our data. We've learned that acknowledging these small things keeps morale buoyant. Even the act of maintenance, often viewed as tedious, has become a source of comfort and pride. When someone tightens a valve or updates a software protocol, they often add a tiny personal touch, an initial on a piece of equipment they serviced, or a short line in the log like, "All good on panel 7, singing a tune while I work." It's part of the ship's culture now to infuse a bit of humanity into the mechanical. Over time, these small acts accumulate into a narrative of care. Walking down a hallway, one can point to a panel and recall, "This was fixed right after New Year's by so-and-so," or see a scuff on a door frame and remember the celebration when we crossed a certain distance milestone. The ship itself becomes a living scrapbook of our journey, full of little mementos and marks left by daily hands. Patience is not merely a virtue here, it's a way of life. We have learned to live in anticipation without anxiety. If a particular experiment will take 6 months to yield results, we set it up carefully and then carry on, knowing time will do the rest. If a transmission to Earth will take decades to arrive, we send it anyway and continue our work in the meantime. In the drift between galaxies, we've discovered a profound lesson. That existence isn't only about the destination or the big breakthroughs, but about the steady breathing of each day. The crew has grown comfortable with waiting for the next scheduled course correction, waiting for the next faint landmark to appear, waiting even for the gentle arrival of sleep each night. In that waiting, we find peace. We fill it with our routines, our creative pursuits, our camaraderie, and the knowledge that every tick of the clock brings us a little closer to our goal. Often, it's the very mundanity of our days that feels miraculous. To sit in the galley and share a simple meal, laughing about a minor misadventure with the ship's plumbing, all while surrounded by a void that stretches for millions of light years. That is a quietly astonishing thing. We sometimes remind each other, this, right now, would be unimaginable to our ancestors. And yet here we are, making it ordinary. And in making it ordinary, we thrive. Routine has become our scaffold for survival and mental health. It gives each person a role, a purpose, a reason to get up, even when the view outside is unchanging darkness. Through drift and patience, we have turned an endless voyage into a string of meaningful days. The notebooks of this journey will one day tell the story of how humans endured the great dark between galaxies, not just with technology and intellect, but with heart and habit. Page by page, they chronicle how a crew of explorers found the sublime in the simple. In one dog-eared notebook, a crew member had once written, "Day 5342. Today, nothing extraordinary happened, and somehow that feels like a gift." I fixed a loose bolt in the greenhouse and helped bake bread in the galley. In the silence of space, the smell of fresh bread reminded me of home. We drift on, and all is well. One day, future generations may read about our little tea gatherings, our jokes and songs, our meticulous experiments and idle observations. They might smile at how we found joy in a tomato plant's blossom, or comfort in a daily coffee routine. These are the threads that, woven together, carry us through the long night. In the end, it may well be the accumulation of these small moments, rather than any single dramatic event, that defines our voyage. Day by unhurried day, with patience and quiet determination, we drift onward, content in the knowledge that we are doing exactly what we set out to do, moving ever so steadily toward a new world and living fully in the space between. After long stretches of emptiness, we sometimes encounter little oases of starlight along our route. One day, the ship's telescopes pick up a hazy glow ahead, too small to be a galaxy like Andromeda, but far brighter than a lone star. As we draw nearer, it resolves into a diminutive galaxy, a scatter of ancient stars bound loosely together. This is a dwarf galaxy, one of the faint companions that drift in the outskirts of the local group. To our eyes, it looks like a tiny smudge of light against the dark, but knowing it is a collection of millions of stars gives us a quiet thrill. It's as if we are passing by a tiny town in the cosmic country, its porch light faintly on, signaling that we're not the only travelers in the night. We treat these encounters as milestones. Long ago, mission planners calculated when we might cross paths with some of these waypoints. When our predictions match reality, when, for instance, we sight a dwarf galaxy within a few light years of its expected position, it bolsters our confidence in our navigation and progress. There's a sense of reassurance. The map of our journey includes these dim beacons, and each time one comes into view right on schedule, we feel a subtle sense of victory. The crew gathers at observation ports to glimpse the dwarf galaxy as we pass. We might spend days or weeks studying it with our instruments, taking spectra of its stars, mapping its shape, learning what we can. Even so, the simple fact of beholding an island of stars up close fills us with quiet awe. In doing so, we pay our respects, as ancient mariners might have done when spotting a known island on the horizon, confirming they had sailed true. Some of these dwarfs have names given by astronomers long before our voyage. Most of the crew aren't professional astronomers, but by now we all speak a bit of that language. We say, "We'll reach the little lantern in another 2 months," using the nickname we gave to a dwarf spheroidal galaxy, whose presence ahead motivates us through the daily grind. Or we'll share stories about how that galaxy was discovered by telescopes centuries ago, barely visible even then, and how incredible it is that now we approach it with our own eyes. Such stories connect us to the generations of humans who only dreamed of this journey. Passing a dwarf galaxy is like walking in the footsteps of those dreams, turning a distant smudge in an old photograph into a real, nearby neighborhood of stars. Not every stepping stone is a full galaxy. Sometimes it's a globular cluster hanging in the void. These globular clusters are dense spheres of very old stars, remnants of the early universe that orbit galaxies like bees around a hive. Occasionally, one has been flung out from its home galaxy or drifts in the far halo, and we are lucky enough to cross its path. We spot it first as a subtle increase in star density, then as a sparkling ball, like a miniature galaxy, but more concentrated. Up close being a relative term, still many trillions of kilometers away, we can distinguish hundreds of individual stars with our telescopes. They shine golden and red, the colors of age, clustered in a sphere. It is a breathtaking sight, a starry snow globe suspended in emptiness. For a time, our sky has a focal point again, and the crew finds excuses to take breaks and simply watch the cluster slowly drift by. In these moments, the void between galaxies feels a little less lonely. Each dwarf galaxy or cluster we pass is a checkpoint on our long road, a dim porch light left on for us by the universe. We often hold a small celebration whenever we reach one. The captain or navigator might give a short speech marking the occasion. Today, we pass the halfway dwarf, or tonight, the stars of the old cluster grace our journey. We cheer, we take group photos against the backdrop of the cluster, its light captured by long exposure on our observation deck's cameras. These rituals, however simple, imprint the significance of the moment on our collective memory. Years from now, someone will recall, "Do you remember when we passed that tiny galaxy and everyone stayed up late to watch it fade behind us?" Then, as always, we move on. The dwarf galaxies and stray clusters slip back into the distance, receding into faintness as we leave them behind. Their presence lingers in our thoughts, though. Knowing they are out there, these small islands of stars, gives us perspective. We realize that even the deep void has its archipelagos, sparse though they are. They remind us that the distance between great galaxies is not completely empty. There are intermediate havens, however humble. In the grand scheme, these stepping stones are still only brief visits. We can't stop long. We cannot explore every star. But passing them has given us renewed inspiration. Each one whispers to us that we're on the right path, that the lights ahead are getting closer, and that even in darkness, there are points of light to guide and welcome us onward. Every so often, the universe offers us a surprise, even out here in the deep black. One quiet watch, our long-range scanners detect an object ahead that doesn't correspond to any known galaxy or cluster. At first we suspect a sensor glitch, but the readings persist. Faint starlight where none should be. As we get closer, we realize we have encountered a rogue star, a sun without a home galaxy, cast adrift in intergalactic space. It glows feebly, a solitary point of light surrounded by nothing but night. Perhaps it was born on the fringes of a galaxy and flung out by a gravitational dance, or it's the survivor of a galaxy that was torn apart eons ago. Whatever its story, it now wanders alone. We adjust our course slightly to study it in passing, not quite believing that here, between the great star cities of galaxies, we have found a lone street lamp burning. The star is a dull red, an ancient dwarf star, nearing the end of its long life. Its light is so faint that we only spotted it because our instruments were attuned to any anomaly. Drawing nearer, we search for any companions it might have. And there it is, a single planet, a rogue world clutched in this star's feeble gravity, circling slowly in the dark. The planet is a frozen sphere, its skies long night, its sun a dim ember. We take what measurements we can: the planet's thin atmosphere, the composition of its surface ice, the star's spectrum hinting at its age. We know we cannot linger too long, but for a brief time we allow ourselves to marvel. Here is a tiny solar system, adrift like a message in a bottle between galaxies. There is a poignancy to this encounter. In a way, that star and its planet are fellow travelers through the void, just as we are. They journey without a galaxy to call home, much as we journey far from ours. We feel a kinship with this solitary system. Some of us gather at the observation deck windows to glimpse the star's dim light directly. It's hardly more than a ruby pinprick to the naked eye, but knowing what it is transforms it into something profound. Someone remarks that, perhaps, in all the infinity of space, we have just doubled the population of this star's admirers. Until now, who else has ever looked upon it with wonder? In the days following, the crew shares quiet conversations about the rogue star. Some speculate about what forces ejected it from its galactic home and how long it has wandered. Others wonder whimsically if any microscopic life might endure on that distant planet, locked in perpetual twilight around its dim sun. We know the chances are remote, yet the mere possibility sparks imagination. In a way, encountering that little star system feels like meeting a traveller coming from the opposite direction, a greeting in the middle of nowhere. If a star and planet can survive out here in the great solitude, It reminds us that our voyage too is survivable, that life and light can persist even in the void. As we glide past, we make a quiet salute. The ship's lights are momentarily dimmed on one side, a symbolic gesture of acknowledgement to the rogue star. We dip our headlights, so to speak, as one might on a dark road upon meeting another lonely traveller. It's a small ritual that wasn't planned, but in the moment, it feels right. There is no practical need to do so. The star will never know. But we will know. We carry on, leaving the star and its lonely planet behind in the endless night, but not without marking its existence in our logs and in our hearts. We name the star Solitaire on our charts, a testament and a promise that it will be remembered by those who passed by. After the encounter, the crew is quietly thoughtful. Such a meeting reminds us of both the vastness of space and the intimacy of sharing it with even one unexpected neighbour. We continue on our course, and that tiny red sun fades back into darkness behind us. Ahead lies more darkness, but also the certainty that there may be other wanderers out here. We keep our scanners tuned and our minds open to wonder. In the expanse between galaxies, even a brief nod to a lone star can light up our sense of connection. We are voyagers, but we are not entirely alone. We share this journey with the rare, solitary travellers of the cosmos, each on their own path through the great night. After an odyssey of unimaginable distance, a subtle change appears in the darkness ahead. Where once the void was nearly absolute, we begin to catch the faintest hint of star glow, not from behind us, but from the space before our bow. At first, it is nothing more than a delicate increase in the pinpoints of light, almost indistinguishable from illusion. But as months pass, and we draw ever closer, the black canvas of space ahead develops a texture. The darkness carries a grain, a faint mottling of distant starlight. We realize with growing excitement that we are seeing the very outskirts of the Andromeda galaxy. We are still far, hundreds of thousands of light years from its core, but already its halo of stars and scattered clusters is greeting us. We proceed gently, almost reverently, into this new realm of light. The ship's trajectory has been calibrated for years to intersect Andromeda's outer halo at a shallow angle to ease our way in. Now we make fine adjustments, slowing our approach as if tiptoeing into a grand cathedral. The space around us is no longer the same deep void we've known for so long. There are solitary stars here, members of Andromeda's extended family, and thin clouds of gas that our instruments detect as a slight uptick in particles. Every day, the view ahead grows richer. The crew takes turns at the observation deck, watching a subtle glow that was once invisible become perceptible. It's like the first light of dawn after a long night, the difference between true darkness and a gentle, diffuse glow that promises morning. Entering Andromeda's halo, we find the environment strangely familiar and yet new. The density of stars is still sparse compared to within a galaxy proper, but after the emptiness between galaxies, it feels as though we have come into a populated neighborhood. Our telescopes pick up the glitter of globular clusters orbiting the galaxy, each a city of stars now within reach of our curiosity. We pass one such cluster at a respectful distance, marveling at its dense heart of ancient suns. These stars belong to Andromeda. For the first time, we are truly among the outskirts of another galaxy. The realization sends quiet waves of joy and relief through the crew. we have made it to our destination's doorstep. Communications that we sent long ago will soon, at last, reach new ears. We broadcast a gentle signal outward, a greeting from travelers arriving at a new shore. Perhaps one day far in the future, it will be received by someone in Andromeda's inhabited worlds, if such exist, or by future humans who come this way. For now, it is enough that the message is sent. It carries our sense of accomplishment, our gratitude for safe passage, and our wonder at what lies ahead. As we venture deeper into the halo, the night sky continues to brighten subtly. The collective light of Andromeda's billions of stars, still distant, forms a pale, ethereal glow across one quadrant of our view. It reminds us of the faint band of the Milky Way we used to see from Earth's nights. Only now, we are outside a new galaxy looking in. This gentle illumination feels like a welcome. Where once there was only emptiness, now there is structure, pattern, and the promise of discovery. We know that beyond this halo lies the vast disk of Andromeda itself, with all its mysteries and possibilities. We travel on with renewed focus, every sensor aimed forward, every heart beating a little faster. Our long journey in the intergalactic darkness is nearly complete. Part 4 of our Odyssey ends not with a sudden finish, but with a gradual, glorious dawn. The first halo of Andromeda envelops us softly, marking the transition from the solitude of the void to the brink of a new cosmic frontier. As we leave behind the pure dark of intergalactic space, we carry with us all the lessons of patience, hope, and perseverance that got us here. Ahead, Part 5 awaits. The moment when humanity truly sets foot, metaphorically and perhaps one day literally, into the realm of another galaxy. But for now, we take a moment to simply drift through this twilight of starlight, savouring the end of one journey and the beginning of the next.